dear students. So next, let's move on to the next thing. And okay, listen here. In the producer consumer, where what we have discussed, in the producer consumer, क्या problem आया था अपने को? Inconsistency problem आया था. Okay. So I'm writing once again. So the problem we faced is inconsistency. So the next thing in the continuation, we'll move on to the next one. Okay, that is printer spooler demon. Understand here. So printer spooler demon. What is the meaning of this? Okay, and what we are going to discuss in this? Let us try to understand. So copy karo, copy this. Keep the heading printer spooler demon, and copy this code here. Copy the code and copy this diagram. So spooler directory, that is SD. Okay, just copy this. A.doc, B.doc, C.doc. So out, that is 0. Okay, so try to copy this. Don't worry, just wait. Let me complete. If board is not visible, just wait. Okay, copy this. You can pause my video and you can copy that. Okay, now listen here. Okay, I am going to discuss. If anybody is still copying, you can pause the video and continue. Okay, after that only you can listen my explanation. Now first listen carefully. Next we are moving on to printer spooler demon problem. Okay, if you are missing anything, okay, you can write down. Okay, when I am explaining everything, I will explain every term, whatever I have written, I will explain. So next we will move on to printer spooler demon. What is the printer spooler demon? Demon means what? Okay, what is demon? Okay, demon means it is not a devil. Okay, right? So demon means background process. Okay, it is just like a technical term. Okay, just a technical term. Demon means a background process. Okay, just like process. Okay, you can say. Okay, in the background it will keep on running. So next printer spooler demon. What is this? First of all, printer spooler demon is a general concept. Okay, listen to me. Printer spooler demon is a general concept used in the printers. Used in the printers. Like for example, if you observe, okay, like internet center outside. Okay, बाहर अपना जो internet center रहता है. In the internet center, what happens? Okay, you will have around 10 systems and all are connected to the common printer. So that's what happens generally, right? You will have around 10 systems and all are connected to the common printer, right? So remember, okay, let us say all the 10 people sitting in the internet center. Listen to me what I am saying. उसको बाद में करेंगे. पहले सुनो मैं जो बोल रहा हूँ. Let's say in the internet center, you are having 10 people. Okay, all the 10 people sitting in the internet center are giving the print command at the same time. All the 10 people sitting in the internet center are giving the print command at the same time. Okay, let's say sub log, okay, they want to print some resume or some file, whatever. So they are giving the print command at the same time. Then what happens? Tell me, क्या होता है? Then it will print all the documents one by one, or it will print only one document. Okay, what happens actually? Okay, remember, okay, what happens? Okay, rest. Okay, it will print all the documents one by one. Now imagine all are giving the print command at the same time. All are giving the print command at the same time. When all are giving print command at the same time, okay, it will print all the documents one by one. So then where your document will be stored? Where your document will be stored? Remember, document will be stored, okay, something called spooler directory. Something called a spooler directory. Remember, every printer will have a small software called, okay, spooler directory. And in the spooler directory, whenever you give any print command, जब भी आप कोई भी print command देते हो, so where the document will be stored first, okay, that will be stored in the spooler directory first. So that is the concept we are going to discuss now. Understand carefully. Is the point clear? Right? So actually, if you want to see this spooler directory, you can clearly see that. वो देख सकते हैं. अगर आपका, okay, if the internet center fellow is your friend, or if somebody is already working in offices like, okay, maybe in IT company, okay, any company, Infosys, TCS, whatever, okay, any company, right, Google, Microsoft also. So you can simply, okay, click on the, okay, printer, okay, so just double click on the printer button. When you double click on the printer button, you can clearly see, okay, कौन सा document कौन print कर रहा है, what is the name of the document, what is the number of pages, okay, who is printing which document. So everything you can clearly see in the spooler directory. I think somebody has seen already, okay. So if you are working already in the IT company, you can clearly, okay, see that. Now that is the concept we are going to discuss. Now, so what is that? What is that means? Listen here, we are having common spooler directory. See, what is spooler directory? Remember, everything is what? Okay, array. Okay, it is just like an array only. So it is having size of okay, 8. So 0 to, okay, 7. Okay, obviously array index start with what? 0. So 0 to, okay, 7. Okay, we are having entries here. Now this is the spooler directory we are having. And next we are having multiple processes. Listen carefully. So we are giving okay, multiple processes. We are having multiple processes. Okay, P1, P2, P3, P4. Remember, you are having multiple processes and you are having only one printer. Remember, in the previous thing, okay, previous explanation, previous concept में producer consumer था. Producer consumer में क्या था? You are having only one producer and you are having only one consumer. Okay, don't confuse. So here you are having multiple processes and one printer. Okay, and next, whenever the process wants to print any file, so that will be placed in the spooler directory first. That will be placed in the spooler directory first. Is the point clear for everyone? Right. So that will be placed in the spooler directory first. Okay. So that is about okay, processes and the spooler directory. And next, what we are trying to do, what is this variables? Understand carefully. You are having in variable and out variable. What is the meaning of in and out variable? Listen here. In is a variable used by all the processes. In is a variable used by all the processes to identify next empty slot in the spooler directory. In is a variable used by all the processes to identify next empty slot in the spooler directory. Okay. Now tell me, what is the next empty slot here? Okay, 3 here. Remember, in is used by what? All the processes. Understand carefully. In is used by all the processes. इसका मतलब क्या है? In is a shared variable. Okay, so don't confuse that. So in is used by all the process to identify next empty slot in the spooler directory. Next, so what is this out here? No doubt. Make a note of this. I think you have not written. No doubt. In is a variable. लिखो notes में लिखो अच्छे से. In is a variable used by all the processes. Used by all the processes to identify next empty slot in the spooler directory. Next empty slot in the spooler directory. Okay, right. So that is about okay, in variable. Next, now what is the out variable? Listen here. Out is a variable used by only printer to identify from where it has to print the document. So कहाँ से document को print करना है? So that is identified by the out variable. Is that clear? Now understand here. Okay, out is now pointing to what? 0. Okay, you are having some files a.doc, b.doc, c.doc like this. So it means first it will print okay, फ्रॉम दियर ओके a डॉट doc ओके इसको प्रिंट करेगा, उसके बाद नेक्स्ट b डॉट doc, उसके बाद c डॉट लाइक दिस ओके इट इज गोइंग टू प्रिंट वन बाय वन डॉक्यूमेंट ओके. सो दैट इज अबाउट द प्रिंटर and that is about the out variable okay. Note down out is a variable, लिखो out is a variable used by the printer to identify from where it has to print the document. To identify from where it has to print the document okay, right. So that is about out variable okay, right. So understand here, so that is about in and out variable okay. Listen here now next okay, what we are trying to do, हम लोग करना क्या चाह रहे हैं, we are trying to provide synchronization to the okay processes okay, to share the common shared variable in and common shared resource spooler directory. Is that clear? Remember okay, printer is not using the in variable, but remember in is used by multiple process. So when it is used by multiple process, it is a shared variable only. When this is also used by multiple process, that is also shared resource only, right? Okay, fine. So next what are the shared resources okay, make a note of this okay. So I write here shared resources. Note down what are the shared resources. The first one is in variable and second one is spooler directory. First one is in variable and second one is the spooler directory okay. So what we are trying to do okay, you are having these two other shared variables here or shared resources. Now tell me, whenever you are having shared resources then these processes are said to be what? आना चाहिए तुमको okay. These processes said to be what? Cooperative process. When they are cooperative processes, you require proper synchronization. Is the point clear for everyone? Right. Next okay, I am repeating once again what we are trying to do. हम लोग करना क्या चाह रहे हैं? We are trying to provide synchronization to the processes to okay access the common to okay okay. So we are trying to provide synchronization to the processes to access the common shared resource spooler directory and common shared variable in okay. So that's what we are trying to do. So this is the code given to you. If any process wants to print the file, they have to okay, they will place the file in the spooler directory first. To place the file in the spooler directory, they make use of this code here. Now understand carefully. Next, I will just go to the code here. The first instruction, load okay in value okay, load the in value into register RI. The first instruction, what you are doing, we are loading the in value into register RI. So I means what? I means respective process register. I means respective process register. Is the point clear? Okay, इसका मतलब क्या है? Respective process register. कॉपी करो अच्छे से. I means respective process register. So इसका मतलब every process will have its own register. Every process will have its own register. इसका मतलब अगर आप process P1 को चला रहा है तो you have to take what? R1. अगर आप P2 को चला रहा है तो you have to take what? R2. So P3 को चला रहा है तो you have to take what? R3. So every process will have its own register. So we are loading in value into register. So M मतलब क्या है? Memory location. ओके, सीओ में आपको समझ में आएगा. ओके, जस्ट लाइक माइक्रो इंस्ट्रक्शंस, इसको क्या बोलते हैं आपका? माइक्रो इंस्ट्रक्शन. यू विल अंडरस्टैंड इन डिटेल इन द कंप्यूटर ऑर्गेनाइजेशन, राइट. सो बेसिक इंस्ट्रक्शंस ओनली. ओके, उतना बड़ा नहीं पढ़ रहे अपन, राइट. सो सेकंड इंस्ट्रक्शन इज व्हाट? स्टोर एफएन. एफएन मतलब क्या होता है? नोट डाउन. एफएन मींस फाइल नेम. फाइल नेम. सो एफएन मींस फाइल नेम. ओके, स्टोर द फाइल नेम ऑफ ए प्रोसेस इन द एसडी ऑफ आरआई. पहले सुनो अच्छे से. ओके, सो स्टोर द फाइल नेम ऑफ ए प्रोसेस इन द एसडी ऑफ आरआई, मतलब स्पूलर डायरेक्टरी ऑफ आरआई. बताओ आरआई में ऑलरेडी क्या है? बताओ इन वेरिएबल है, तो इसका मतलब एम्प्टी स्लॉट में अपन ओके फाइल को अपन स्टोर कर रहा है. एंड नेक्स्ट आफ्टर दैट यू आर इंक्रीमेंटिंग रजिस्टर वैल्यू. Okay, after incrementing register value, then what you're doing? We are storing the incremental register value back into invariable, So remember, this is the code, okay, used by the processes, okay, to access the spooler directory. Now, what we have to do? अभी करना क्या चाहिए अपने को? Okay, we need to do the analysis. We need to do the analysis and understand what is the problem here. हम लोग क्या बताना चाह रहे हैं, क्या डिस्कस करना चाह रहे हैं? Let us do the analysis. So, I am writing here. Okay, listen carefully. Analysis. So, okay, I am going to explain the analysis. So, in the analysis, okay, I am assuming, okay, just listen here. In the analysis, I am assuming in the redo queue, we are having two processes. Okay, is it visible or not visible? Red marker. Okay, so I don't use this. Okay. Okay, so listen here. So, I use block one only, black color, so comfortably visible. I am assuming in the analysis, I am assuming, let's say in the ready queue, we are having two processes. P1 is trying to print some document xyz.doc and P2 is trying to print some document pqr.doc. Okay. Okay. So, in the analysis, okay, we are assuming that I am assuming we are having ready queue. Okay, in the ready queue, we are having two processes P1 and P2. P1 is trying to print document xyz.doc and P2 is trying to print document pqr.doc. So, observe carefully what is going to happen. So, हम लोग क्या बताना चाह रहे हैं, अच्छे से observe करो. Now, tell me what is the in value. Okay, सारे values आपके सामने हैं. Okay, in value क्या है बताओ? 3. In value is 3. So, now first process P1 is okay trying to print the document. So, P1 is executing first instruction. The answer सुनो अच्छे से, analysis बता रहा हूँ. P1 is okay trying to print the document. P1 ये document print करना चाह रहा है. Print करना है तो क्या करना? Okay, ये instructions को चलाना पड़ेगा. Simple, right? So file को okay spooler directory में store करना है तो वो पूरा instructions को execute करना पड़ेगा. So P1 is executing the first instruction. What is the first instruction P1 is executing here? Load the in value into register. So load the in value into register. So what is the in value you are having here? 3. Okay, observe carefully. Okay, I think it is visible. So load the in value into register. So in value is okay 3. So we are loading. I am taking separate register. Okay, that is register R1. Remember, every process will have its own register. I told you already. So load the in value register. So what is the in value you have here? In value is 3. Loading the in value into register. And next, now P1 executing second instruction. Now tell me, what is the second instruction you have? Second instruction, store the file name of a process in the spooler directory of RI. Okay, listen carefully. Store the file name of a process in the spooler directory of RI. So RI means what? R1. R1 मतलब what is the value here? 3 here. तो इसका मतलब ये file name, process का जो file name है SD of 3 में आपको store करना है. So what is the file name the process is having? You have to store that in the SD of 3. So what is the file name the P1 is having here? xyz.doc. So P1 file name is xyz.doc. So let's store this file in the SD of 3 here. So SD of 3 मतलब spooler directory of 3. So we are going to store that. So what is the file name here? xyz.doc. And next, now let us say after that, now P1 executing the third instruction. P1 executing third instruction. What is the third instruction? Increment register value. Now understand here, when you increment the register value, so what happens? Register value becomes what here? 4. Register value becomes 4 here. And let us say, the answer is not just say, after executing third instruction. After executing the third instruction, I am assuming that process P1 is getting preempted. I am assuming that process P1 is getting preempted. So listen carefully. After executing our third instruction, I am assuming that P1 is getting preempted. Now remember, okay, P1 is getting preempted. Now let us say we are scheduling some other process. Okay, मैं बताया था. Okay. प्रीएम्पशन कभी भी हो सकता है, कहां पे भी हो सकता है, आफ्टर कंप्लीशन ऑफ द करंट इंस्ट्रक्शन. That is the universal assumption we have seen in the previous session, okay, in the previous code. Running process may get preempted at any point of time after completion of the current instruction. After completion of the current instruction, I told you already, right? So I am assuming P1 is getting preempted after third instruction. मतलब क्या है? Simple. Okay, अभी उसका time quantum expire हो गया. Assume the time quantum is expired and it is going from running state to what? Ready state. That is the meaning of this. And next, let us say after that we are scheduling process P2. Now P2 executing the first instruction. P2 executing the first instruction. What is the first instruction? Okay, remember, okay, code is same for all the process. So I have to take the separate register for the P2. Let's say that is R2. Okay, now tell me, P2 executing first instruction, load the in value into register. So for the P2 I will take separate register R2, load the in value into register. Now tell me, what is the in value you have? What is the in value? In value क्या है? कुछ लोग सोच रहे हैं 4. थोड़ा सुनो, अच्छे से सुनो. Okay, right? In value modify नहीं हुआ यहाँ पे. In value कितना है? 3 है. In value is not yet modified. In value is still 3 only because I have not executed the store instruction. Okay, after third instruction only we have preempted. So in value is not modified. It is in front of you. It is visible, right? Okay. Now understand here. So P2 executed first instruction, load the in value into register. So what is the in value you have here? 3. So when you load that instruction, okay, in value into register. So that is 3. Next, now P2 executing the second instruction. Now look at here. So P2 executing second instruction. Now when P2 executing second instruction here, what is the second instruction? You have store the file name of a process in the SD of RI. Store the file name of a process in the SD of RI. What is the file name the process P2 is having here? P2 is having what? pqr.doc. That is the file name it is having. So look at here. So P2 is having pqr.doc and that will be stored into what? Okay, in the SD of RI. What is the RI value? RI matlab with respect to P2. What is that here? R2. What is the value inside? 3. तो मतलब SD of 3 में file name को store करना है. What is the file name? P2 is having pqr.doc. So वो कहाँ पे store करना? SD of 3 में store करना. अगर आप SD of 3 में store कर रहा है तो क्या हो जाएगा अभी? बताओ, SD of 3 में store कर रहे हैं. So this will be replaced with the, what is the file name we are having SD of 3 में? File name pqr.doc. pqr.doc. It is replaced with this. Now look at here. Now process P2 executed second instruction. But what happened? What is the problem you observed here? Okay, क्या problem समझ में आया? Whatever the file the process P2 has placed, that is overwritten by process okay P2 file. Whatever the file the process P2 is having, whatever the file process P1 has placed, that is xyz.doc, that is overwritten by process P2 file. P2 file क्या है बताओ? pqr.doc. Is that clear? So this is called as a second problem, and this problem is called as second problem. This problem is called as loss of data. Second problem, that is called as what? Loss of data. Is that clear? So copy everything carefully. So take it as analysis. Okay, analysis ये copy करो. P1 P2 है ready queue में. Okay, ये पूरा analysis steps copy करो और यहाँ पे modify करो. xy.doc इसको cut करके ये change करो. Okay, so copy everything carefully. Analysis. Okay, I will explain properly. Okay, आपको क्या doubt आता है पता है? I'll discuss all that. I'll give the notes also. Statement मैं बताता हूँ. So just copy this first. You can pause my video. If you are copying, you can pause my video. I will wait 5 to 10 seconds. Okay. Now understand here. So if anybody is still copying, you can pause and continue. Okay, copy. And after that you can continue play the video. Right. Now what is the problem here? What is the problem? The first problem. Okay, this problem. What is the problem here? Loss of data. See why this problem is coming? Why this problem is coming? Remember, processes are not properly synchronized. Processes are not properly synchronized. while sharing the common variable in. While sharing the common variable in, okay, that is the reason, okay, it is leading to the problem of what? Loss of data. That is the reason it is leading to the problem of what? Loss of data. Is the point clear? Right. I'll give the notes, don't worry. And the next, okay, somebody will have a doubt, okay, small doubts you will have, okay, so same doubt, okay, many people are having. So why I am taking preemption after third instruction? You will have this doubt. So why I am taking preemption after third instruction? Now tell me, what is the answer? Answer is no answer. Right. So answer is no answer. It means what? Preemption may occur at any point of time after completion of the current instruction. Is that clear? Remember, preemption यहाँ पे भी हो सकता है, preemption यहाँ पे भी हो सकता है, okay, preemption यहाँ पे भी हो सकता है. Okay, I am just assuming that, okay, it is getting preempted after third instruction. I am assuming that it is getting preempted after third instruction. Okay, क्योंकि preemption कभी भी हो सकता है, because अपन round robin से चला रहा है, क्योंकि multitasking operating system है. मल्टीटास्किंग अगर आपको चाहिए तो आपको राउंड रॉबिन यूज करना पड़ेगा. राउंड रॉबिन अगर आप यूज कर रहे हैं तो टाइम क्वांटम कभी भी एक्सपायर हो सकता है. इज दैट क्लियर? राइट. नाउ लिसन टू माय स्टेटमेंट वेरी केयरफुली. द आंसर सुनो अच्छे से. रिमेंबर, इफ ऑल दीज इंस्ट्रक्शंस आर एग्जीक्यूटेड विदाउट एनी प्रीएम्पशन, इफ ऑल दीज इंस्ट्रक्शंस आर एग्जीक्यूटेड विदाउट एनी प्रीएम्पशन, द सॉल्यूशन मे वर्क फाइन. If all these instructions are executed without any preemption, the solution may work fine. But remember, you cannot guarantee the preemption will never arise. You cannot guarantee that preemption will never arise after the third instruction. You cannot guarantee that preemption will never arise after the third instruction. Okay, so it means what I am trying to say, if the preemption occurs after the third instruction, then okay, that leads to problem of what? Loss of data. अगर यहाँ पे preemption होता है तो that will lead to the problem of what? Loss of data. Is that clear? So that is the second problem here. It means what? अभी important point दूसरा एक समझ में आना चाहिए. जो भी solution आप लिख रहे हैं, कोई भी problem के लिए solution आप लिख रहे हैं, whatever your solution you are writing for any kind of problem, it should work correct, it should work perfect, it should work error free, okay, even though there is a preemption. That is how you have to write the solution. It is not like, okay, it is working fine, okay, sometimes without preemption, okay, but it's giving problem, okay, when you apply preemption. So that is not the correct solution. Is the point clear for everyone? Right? So here, if you take the preemption, that is leading to the problem. Okay. What is the problem here? Loss of data. So no doubt, keep the heading loss of data. I will give the statement. Keep the heading loss of data. No doubt, the processes are not properly synchronized. Processes are not properly synchronized while sharing the common variable in, hence it is leading to the problem of loss of data. Leading, L-E-A-D-I-N-G, leading to the problem of loss of data. Is that clear? So that is the second problem we are having if we don't have proper synchronization. Okay, right? So मतलब synchronization अगर आप नहीं है तो what is the first problem you get? Inconsistency. Second problem you get loss of data. And next, okay, note down the next one. Keep the heading directly. Keep the heading. Third one, next one. The third one is deadlock. Third problem is the deadlock. Okay, note down. I'll explain. Keep the heading number 3, deadlock. Keep the heading number 3, deadlock. Note down the statement. If the processes are not properly synchronized, Note down, if the processes are not properly synchronized while sharing the common variables or common resources, then it is also possible for loss of data. Sorry, it is also possible for deadlock. Sorry, also possible for deadlock. Okay, right. So I am repeating. Okay, so when the processes are not properly synchronized while sharing common data or common variables or common resources, there is also possible for what? Deadlock. Okay. So process के बीच में proper synchronization नहीं है, okay, while sharing the common variables or resources or anything, so it is also possible for what? Deadlock. So how this deadlock is going to occur? How the deadlock will occur? So that you will understand going forward. Okay. So going forward, we will discuss the so many problems, so many examples in which the deadlock will arise. So it means you need to understand that if you don't have proper synchronization, between the processes, then it is also possible for what? Deadlock. Right. So these are the three major problems we are going to get. if we don't have proper synchronization. So the first problem is what? Inconsistency. And second problem is loss of data. And third problem is deadlock. और deadlock कैसे होगा? So आगे आपको समझ में आएगा. Okay, बस याद रखो कि ये तीनों problems आएगा. Right. So remember how you are going to avoid these problems and how you are going to provide the correct solution to the processes. How you are going to provide correct solution to the processes, that we are going to study going forward. Is that clear for everyone? Right. Okay. So that is okay, three problems. Okay. So that is about okay, the first problem, first step. Step number 1 we have completed. Okay, I told synchronization I will discuss in the 3 steps. The first step is what? Conditions to first step is problems arises not having synchronization between the process. So अभी आपको समझ में आया process के बीच में synchronization नहीं है तो ये problems आएगा. So with this we have completed step number 1. Next, so we'll move on to the next. Before we move on to the step number 2 जाने से पहले we are having some definitions. So just note down, keep the heading definitions. Keep the heading definitions. Okay, we'll study some small definitions and later we will enter into step number 2. So in the definitions, the first definition, note down, critical section. Note down, the first step is a critical section. So what is the meaning of critical section? Okay, note down, keep that in critical section. Note down, the portion of program text, where shared resources, okay, you continue, I am not writing, you please continue. The portion of program text where shared resources or shared variables are placed, P-L-A-C-E-D, placed. Okay, so understand here. So going forward, I am going to use the term. Going forward, I will use the term called critical section. So it means whenever I say critical section, listen here. Whenever I say critical section, you need to understand portion of program text where shared variables, okay, shared variables or shared resources are placed. So it means what? Critical section मतलब क्या होता है? Okay, we will have the shared variables or the shared resources. So going forward, whenever I say critical section, so what you need to understand? Okay, you will have some shared variable inside or shared resource inside. Now tell me, according to the previous examples what you studied, okay, if you observe that, okay, producer and consumer. When you study producer consumer, in the producer consumer, okay, what is called as a critical section? Okay, example, what is called as critical section? Okay, आना चाहिए idea तुरंत. Okay, count equal to count plus 1. Count, okay, count equal to count plus 1 or count equal to count minus 1. Okay, anything you can take. Okay, remember count is a shared variable there. Okay, producer consumer में count shared variable था. Okay, so we can call that as what? A critical section. Right, so that is about critical section. Next second, no doubt. Next is a non-critical section. No doubt. Non-critical section. The portion of program text, same, the portion of program text where the independent code of the processes, where the independent code of the processes will be placed. Independent code of the process will be placed. Okay, so independent code means what? The code which belongs to only that particular process. Independent code मतलब सिर्फ उसी का code है. Okay, वही process execute करेगा. Okay, code which belongs to only that particular process, that is called as a independent code. Now tell me, with respect to producer and consumer, which is called as a non-critical section. Producer consumer में non-critical section किसको बोलते हैं? Okay, example, okay, in equal to in plus 1 mod n. Okay, you can take a, okay, in equal to in plus 1, or you can say out equal to out plus 1. Okay, why? Because in is independent to only producer and out is independent to only consumer. Okay, so I think you know that already. So that is called as what? Non-critical section. Okay, next, no doubt, the next one, number 3, third definition, race condition. Number 3, we have a race condition. Okay, no doubt, race condition, the final value of any variable, the final value of any variable depends on execution sequence of the processes. Okay, the final value of any variable depends on execution sequence of the processes. Okay, so final value of any variable depends on execution sequence of the process. Okay, इसका मतलब क्या होता है? Okay, look at here. So let's take the example. Okay, you will understand that. Don't worry. Example, अगर आपको देखना है example, so just go to producer consumer analysis. नोट्स में जाओ. ओके, टर्न योर पेजेस, 1 या 2 पेज पीछे जाओ. प्रोड्यूसर कंज्यूमर का एनालिसिस देखो. प्रोड्यूसर कंज्यूमर, जस्ट लुक एट द प्रोड्यूसर कंज्यूमर एनालिसिस. ओके, व्हाट यू हैव डन देयर? ओके, इन द प्रोड्यूसर कंज्यूमर एनालिसिस, सो फर्स्ट आई स्टार्टेड विद द प्रोड्यूसर. Okay, I have executed 2 instructions. After that I have taken the preemption, and after that I executed consumer. Okay, so like consumer का 1 2 3 instructions चलाया. Okay, I executed consumer for 3 instructions, and after that okay, producer का okay 3rd instruction चलाया. After that we executed 3rd instruction of the producer. Now remember, okay, if I executed in this manner, what was the final value of the count we got there? Count value कितना आया था अपने को? 4 आया था. Okay, ये एग्जाम्पल अगर ऐसा चलाया अपन, ऐसा चलाया तो काउंट वैल्यू कितना आया था बताओ? 4 आया था. नो रिमेंबर वहां पे जरूरी नहीं है कि वो एग्जाम्पल में जरूरी नहीं है कि ओके अपने को हमेशा ओके प्रोड्यूसर से ही पहले चालू करें. Okay, in that example, there is no guarantee that we should always start with the producer first. Remember, we can also start with what? Consumer first. So, if I start with the consumer first, then what happens? Okay, in that example, if I would have started with the consumer, then what happens with the count value? Listen here, I executed consumers 2 instructions and I have taken the preemption, and then I executed producer, okay, 1, 2, 3 instructions, producer 1, 2, 3 instructions. And after this, okay, I have executed consumer third instruction. After that, I have executed consumer third instruction. Okay, so now understand here, okay, if I follow, okay, this sequence here, okay, we started consumer 2 instructions, after that preempted and producer का 3 instruction चलाया, उसके बाद वापस consumer का 3rd instruction चलाया. If I followed this sequence, okay, what would be the count value? What would be the count value? Okay, count value will be what? 2. Okay, so इसका मतलब कंज्यूमर का रजिस्टर में जो वैल्यू है वो फाइनली काउंट में जाता था. कंज्यूमर का रजिस्टर में जो वैल्यू है ओके फाइनली काउंट में जाता है. ओके, व्हाट इज द वैल्यू इन द आरसी? देखो वहां पे एनालिसिस में देखो, प्रोड्यूसर कंज्यूमर का एनालिसिस में आरसी में क्या वैल्यू है? आरसी में 2 है वैल्यू, राइट. सो कंज्यूमर का ओके रजिस्टर में जो वैल्यू है वो फाइनली काउंट में जाता था अगर मैं ये सीक्वेंस फॉलो किया होता. So consumer का रजिस्टर में क्या वैल्यू है? 2 है. So it means if I execute this sequence, you get count value as a 4. If I follow this sequence, you get count value as 2. It means the final value of any variable, depends on execution sequence of the processes. Yes, if I follow this sequence, you are getting count value 4, and if I follow this sequence, you are getting count value 2. So that kind of okay variable, this kind of situation is called as what? Race condition. That is called as race condition. Remember, so going forward, I'll say these terms. Okay, these are the simple definitions. Going forward, I'll say critical section. तो क्या समझना है? Shared variable रहेगा. नॉन क्रिटिकल सेक्शन क्या समझना है? इंडिपेंडेंट कोड रहेगा. रेस कंडीशन क्या समझना है? ओके, फाइनल वैल्यू ऑफ वेरिएबल चेंज हो सकता है, कभी एक हो सकता है, कभी दूसरा हो सकता है. ओके, ऐसा. ओके, दैट इज द मीनिंग ऑफ दैट. ओके, सो दैट इज कॉल्ड एज रेस कंडीशन. सो फाइनल वैल्यू ऑफ एनी वेरिएबल डिपेंड्स ऑन एग्जीक्यूशन सीक्वेंस ऑफ द प्रोसेसेस. सो दिस टाइप ऑफ कंडीशन इज कॉल्ड एज व्हाट? रेस कंडीशन. सो दिस इज द एग्जांपल. कॉपी करो, ये कॉपी करो, टेक इट एज एग्जांपल, कॉपी दिस. कंटिन्यूएशन में okay, right. So next, now understand here, continuation, keep it as note, keep it as note. Keep it as note. Note down the statement. एक statement लिखो, simple statement लिखो एक. Keep it as note. This is a important note. Star लगाओ यहाँ पे, important note. Note down. To avoid the problem of race condition. To avoid the problem of race condition, only one process should be present. Only one process should be present inside the critical section. Only one process should be present inside the critical section at any point of time. Only one process should be present inside the critical section at any point of time. Okay, so इसका मतलब क्या होता है? What is the meaning of this? You will understand that later. Okay, but remember that is an important note. To avoid this problem of race condition, only one process should be present inside the critical section at any point of time. इसका मतलब क्या होता है? आपको समझ में आएगा. बस उसको याद रखो, वो important है. आपको आगे थोड़ी देर के बाद आपको अपने आप समझ में आएगा. समझ में नहीं आए तो खुद से समझ में आना चाहिए, समझना चाहिए. Okay, you will understand anyway. So no need to worry about that. Okay, fine. So now with this we completed the step number 1. Okay, only step number 1 we completed. What is the step number 1? Problems arises not having synchronization between the process. Okay, what problems will arise? Okay, I am repeating: inconsistency, loss of data and deadlock. Okay, and these are the definitions, simple definitions. Is that clear? So next, okay, slowly we will enter into the step number 2. Okay, thank you. Okay, So dear students, next we'll move on to the next step. So in the previous step, okay, step number 1, we understood the conditions to be followed to, the problems arises not having synchronization between the processes. So we understood the problems. Kya problems aayega? Okay, that is the first one is what? Inconsistency, second one is loss of data, and third one is a deadlock. Okay, that is the step number 1 completed. Next we'll move on to the step number 2, that is the conditions to be followed to achieve synchronization. The conditions to be followed to achieve synchronization. Copy karo. Note down the step number 2. The conditions to be followed to achieve synchronization. Remember, maintain the proper notes. Okay, remember it is just like a regular class. Okay, remember, if you don't maintain the regular notes, what is the problem? The problem comes at the time of revision, because okay, you have to do the revision in the regular intervals, obviously, right? So if you don't make the proper revision, so you'll have a problem. Okay, so revision करने के लिए क्या चाहिए पक्का? Proper notes चाहिए, क्योंकि बार बार वापस आके आप वीडियो नहीं देख सकते, because this video is having, I think, time bound limitation. एक बार देखना, दो बार देखना, I don't have idea. So I'm telling you, okay, maintain proper notes, just like you are sitting in a class. Understand that, okay? And moreover, I will not discuss any unnecessary things. I will discuss only to the point, okay, what is required only. So, okay, no need to refer any outside material and all these things. I told you in the first day class only, okay, right? Okay, so understand here the conditions to be followed to achieve synchronization. So, synchronization achieve करने के लिए, okay, proper synchronization achieve करने के लिए क्या conditions चाहिए? What condition we should follow? Now, understand here the first condition you have to follow. The first condition you have to follow is mutual exclusion. Okay, note down. So generally you call it as a ME, okay, when you are solving problems. Okay, the first condition you have to follow is a mutual exclusion. Now remember mutual exclusion. What is the meaning of mutual exclusion? Note down. Okay, keep the heading. First condition, mutual exclusion. Note down the statement. Note down. No two processes. First condition is a mutual exclusion. Keep that heading. Note down. First, no two processes may be simultaneously present. I am not writing here. You have to continue. मैं यहाँ पे नहीं लिख रहा हूँ. Continue करो. No two processes may be simultaneously present inside the critical section. Inside the critical section at any point of time. At any point of time. Full stop. Note down. Next point. Okay. Mutual exclusion means next point. Only one process. Okay. Only one process should present inside the critical section. Inside the critical section at any point of time. Only one process should present inside the critical section at any point of time. Now, understand here, okay, logical meaning of both the statements is the same only. Okay, understand here. What the first statement says? No two processes may be simultaneously present inside the critical section. Okay, so इसका मतलब क्या है? वो थोड़ा technical statement जैसा है. Okay, but second statement is a okay simple meaningful statement. What the second statement? Only one process should present inside the critical section at any point of time. Now tell me, what is the meaning of critical section? First point, critical section means what? Shared variables or shared resources. I told you already, right? So, okay, in the critical section, only one process should present inside the critical section. इसका मतलब क्या है? If at all you are having, okay, what is the meaning of this? If at all you are having any shared variables or shared resources, only one process should make use of the shared resources at any point of time. That's the meaning, okay? That's the meaning of mutual exclusion, okay? So, only one process should present inside the critical section at any point of time. So, that's the first condition you have to follow to achieve the proper synchronization, right? Now, remember, if you observe the producer-consumer problem, if you observe our producer-consumer problem, okay, what was the problem we had in the producer-consumer? Tell me, what was the problem? क्या problem आया था producer consumer में? Inconsistency problem आया था. Very good. So inconsistency problem आया था. Okay. थोड़ा logically समझो. Try to understand logically why that inconsistency problem was arised. Okay, because two processes, producer and consumer, both are trying to update the shared variable count. Producer and consumer both are trying to update the count variable, that is a shared variable at the same time. Okay, count is a shared variable there. So that is the reason we had a problem of what? Inconsistency. Now what this condition is saying, if at all you are having that kind of shared resources, if at all you are having that kind of shared variable, only one process should make use of the shared resources, okay, at any point of time. So it means going forward, you represent the shared resources with the simple term called critical section. Going forward, you represent the term, okay, shared resource with the critical section only. By critical section, ऐसा लिख दूंगा. I'll simply write the critical section in the box. It means what? There is a shared resources inside that, and only one process should access the shared resources at any point of time. Is that clear? So critical section के अंदर भी क्या होगा? Set of instructions होगा. Is that clear? That's it. Don't worry, you will understand that. I will explain in detail. So only understand this point. Wherever you are having critical section, only one process should present. Wherever you are having shared resources or critical section, only one process should make use of that. Okay, that's the first thing. Now remember, producer consumer में अपने को जो inconsistency problem आया था, okay, क्यों आया था? Because two processes are trying to access the count variable at the same time. Remember, this condition says if you are having that kind of shared resource, shared variable, only one process should make use of that. So in that case, there is no possibility of what? Okay, inconsistency problem. That will be straight away ruled out. The problem is straight away, okay, removed or ruled out. Okay, now, so that is the first condition you have to follow. And the next, okay, the second condition you have to follow is, okay, note down, that is progress. Okay, second condition you have to follow is a progress. Okay, note down all the points carefully. Okay, I am going to write some points here, some points you have to dictate. Sometimes I say, okay, dash, dash, dash. Okay, you have to continue. Okay, right, because I cannot write everything in the board. Okay, board is also small. Okay, right. Okay, note down first statement in the progress. First statement, no process running outside the critical section, no process running outside the critical section should block other interested process from entering into critical section, when critical section is free. Okay, so understand here. Okay, so understand this here, progress. No process running outside the critical section. No process running outside the critical section should block the other interested process from entering into critical section, okay, when critical section is free. Okay, so this is okay, underline karo isko, when critical section is free. So what is the meaning of this? Don't worry, I'll explain everything in detail. Pehle likhenge apan. And next, note down second point. If there is only one process, continue karo. If there is only one process trying to enter into critical section, then it should be definitely allowed to enter into critical section. Okay, next, note down the next point. Okay, progress mein third point. If two or more processes trying to enter into critical section, if two or more processes trying to enter into critical section, then one process should definitely enter into critical section. One process should definitely enter into critical section. Okay, right. So now come back to the understanding of all these statements. Okay, remember the answers say, okay, many people will confuse in this. Okay, we'll solve so many questions. I will remove all your confusions. Okay, understand here. First of all, okay, what is this here? Progress. Progress means, what is the English meaning of progress? Okay, don't worry and all this. Simple. English meaning, progress means what? English meaning, progress means something should continue. कुछ तो चलना चाहिए, right? So life में कुछ progress होना चाहिए, मतलब कुछ तो चलना चाहिए, right? So progress means all the same thing. Okay, somebody should continue, somebody should execute when the critical section is free. Now, what is the meaning of first statement? Listen first, one by one. No process running outside the critical section should block the other interested process from entering into critical section when critical section is free. Understand here. Okay, इसका मतलब क्या है? Okay, let us say you are having critical section. Let's say critical section मतलब क्या है? Okay, क्या होगा? Shared resources, shared variables है. Now critical section is free. Remember that point is important. Critical section is free. So I am talking the definition of the progress only when the critical section is free. So I am not saying anything when the critical section is busy. I am not saying anything when the critical section is busy. Is the point clear? Right. So listen here. Now critical section is free. Nobody is there in the critical section. Okay, look at here. No process running outside the critical section should block the other interested process from entering into critical section when critical section is free. Now listen here. Critical section is free here. Now process P1 is trying to enter into critical section. Critical section free है, shared resources खाली है. So P1 अभी उसको use करना चाह रहा है. But remember, some other process running outside the critical section, some other process P2, let's say it is running outside the critical section, is blocking the P1 not to enter into critical section. ऐसा नहीं होना चाहिए. Okay, now some process P1 is trying to enter into critical section, but some other process which is running outside the critical section is blocking the P1 not to enter into critical section. Okay, ऐसा नहीं होना चाहिए. Okay, I am repeating this statement. No process running outside the critical section. No process running outside the critical section. Who is running outside the critical section? Process P2. Okay, should block the process P1 from entering into critical section when critical section is free. So, मतलब जब critical section free है, P1 जाना चाह रहा है, but P2 इसको रोक रहा है. ऐसा नहीं होना चाहिए. Okay, इसका मतलब, लॉजिकल मतलब क्या हुआ? इसका मतलब सिंपल इतना ही हुआ. When critical section is free, whoever is interested, that should be allowed to enter into critical section. When critical section is free, some progress should be there. It means someone should definitely make use of the shared resources. When critical section is free, whoever is interested, that should be definitely allowed to enter into critical section. But somebody is, okay, outside process, which is not interested, which is running outside the critical section, is blocking the P1 not to enter into critical section. Okay, it should not happen like that. Okay, right. Don't worry, everything will be clarified. एक ही statement में, एक ही 10 मिनट में पूरा समझ में नहीं आएगा. थोड़ा वेट करो, right? And next, second point क्या है? If there is only one process trying to enter into critical section, then definitely, okay, it should be allowed to enter into critical section. It means what? Okay, look at here. Let's say critical section you are having. Now critical section is free. Nobody is, okay, using the shared resources, shared variables. Now only one process is trying to enter into critical section. अभी कोई दूसरा प्रोसेस नहीं है, दूसरा प्रोसेस इंटरेस्टेड नहीं है, कुछ भी नहीं है, कुछ भी एग्जीक्यूट नहीं हो रहा है, वो शेड्यूल ही नहीं हो रहा. ओके, राइट, शेड्यूल ही नहीं हुआ. नाउ देयर इज ओनली वन प्रोसेस ट्राइंग टू एंटर इनटू क्रिटिकल सेक्शन, देयर शुड बी डेफिनेटली अलाउड टू एंटर इनटू क्रिटिकल सेक्शन. Now remember, only one process is trying to enter into critical section, but it's not allowed. It means what? Obviously, progress is not there. Shared resources खाली है, मगर अपन उसको यूज नहीं कर रहे हैं. Okay, process को अलाउ नहीं कर रहे हैं यूज करने के लिए. Obviously, there is no progress, right? And next, now third statement क्या है बताओ? If two or more processes, listen carefully. Two or more processes, okay, are trying to enter into critical section. Okay, two or more processes are trying to enter into critical section. Then, okay, one process should be definitely allowed to enter into critical section. Now look at here. So let's say you are having critical section here. You are having critical section. there is no process present in the critical section. There is no process present in the critical section. Two or more processes are trying to enter. Let's say, look at here. P1 is trying to enter. P2 is trying to enter. Okay. P3 is also trying to enter. P4 is also trying to enter. Just example I am saying. Two or more processes are trying to enter into critical section, then one process should definitely allow to enter into critical section. Remember, obviously only one process should be allowed, because if you allow two processes, what happens? Obviously mutual exclusion will fail. Obviously एक ही process जाना चाहिए. If two or more processes are trying to enter, okay, one process should be definitely allowed to enter into critical section. Obviously एक ही process जाना चाहिए. अगर दो process जा रहा है तो obviously mutual exclusion fail होगा. Now remember, if two or more processes are trying to enter into critical section, one process should be definitely allowed. Remember, two or more processes are trying to enter, but nobody is entering into critical section. Two or more processes are trying to enter, but nobody is entering into critical section. Why they will not enter? Maybe you have written the code like that. You have written the code like this. Now P1 is depending on P2, P2 depending on P3, P3 depending on P1. Okay, something like that. Okay, P3 also depending on P4 depending on P1. So all are depending on each other, and nobody is going into critical section. Nobody is entering into critical section. Okay, remember, two or more processes are trying to enter, but nobody is entering into critical section. What is that means? That means it is a deadlock in the system. Okay, your code is such a way that, okay, P1 depending on P2, P2 depending on P3, P3 depending on P4, okay, maybe some code you have written, okay, nobody is continuing further execution in the system, okay, nobody is, okay, going into critical section, nobody executing the further execution, okay, in their code. It means what? Okay, while loop हो गया, while loop में stuck up हो गया सारे process है, okay, ऐसा code लिखा है आपने. So it means that is called as what? Deadlock. So it means when there is a deadlock, there is no progress. Obviously, deadlock means what? There is no further progress. Right? So, two or more processes are trying to enter, definitely one process should enter into critical section. Is the point clear for everyone? Right? Now, remember, the meaning of all these statements, all the three statements is same only. There is no difference. The logical meaning of all the three statements is the same only. Now, I will tell you one more thing. Okay, different textbooks will give you different definition. Like, I will give you one more definition also. Just listen only. Just listen only. Okay, the process which is trying to enter into critical section, okay, it should take its own decision to enter into critical section. Some textbooks will say this. I am repeating. Which process should enter into critical section is decided by that particular process only. Some other process should not take the participation. इसका मतलब क्या है? जो प्रोसेस जाना चाह रहा है वो खुद का डिसीजन लेना चाहिए, दूसरा प्रोसेस के ऊपर डिपेंडेंट नहीं होना चाहिए. मतलब वो परमिशन दिए तो ये जाएगा, ओके, राइट, ऐसा नहीं होना चाहिए. अगर जाना है तो वो खुद ही जाना चाहिए. सिंपल सी बात है, राइट. इसका भी मतलब क्या हुआ? सेम हुआ. सारे स्टेटमेंट्स का मतलब सेम ही हुआ. ओके, इसका मतलब व्हाट इज द मतलब क्या है? सॉरी व्हाट इज द मतलब बोल रहा हूं, हिंदी इंग्लिश मिक्स हो गया, सॉरी, राइट. ओके, इसका मतलब क्या हुआ? इसका मतलब ये हुआ, simple, the meaning of all the three statements whatever I have given and four statement also, okay, meaning of all that is same only. Simple, when the critical section is free, whoever is interested, that should definitely enter into critical section. Simple, right? Okay, don't worry. Okay, it looks very big, but it's very simple. I'll show you the simple techniques and all that. Okay, right. So whenever the critical section is free, whoever is trying to enter, you should definitely enter into critical section. Okay, that's all. That is the meaning of the progress. Okay, right. So logical meaning of all the three statements is the same only. Okay, understand that point. So next, that is the second condition you have to follow. Okay, that is the second condition you have to follow. And the next, the third condition we have to follow is, bounded waiting. Third condition we have to follow is a bounded waiting. So what is the meaning of bounded waiting? Okay, understand this carefully. Bounded waiting means, okay, note down various points, later we will discuss. Note down the first point, no process should have to wait. No process should have to wait forever forever to enter into critical section. No process should have to wait forever to enter into critical section. So that is the first statement. And the second statement, note down. Some process, second statement, cut karo. There should be a, note down, second statement, there should be a bound on, B-O-U-N-D, bound on getting chance to enter into critical section. There should be a bound on getting chance to enter into critical section. Second statement. Next, third statement. Note down properly, make a proper notes. Note down the third point. Some processes indefinitely waiting. Some processes indefinitely waiting to enter into critical section. Some processes indefinitely waiting to enter into critical section because critical section is always busy by some other processes. Critical section is always busy by some other process. Some process is indefinitely waiting to enter into critical section because critical section is always busy by some other processes. Continuation. This situation should not arise. This situation should not arise. So some processes are indefinitely waiting to enter into critical section because critical section is always busy by some other processes. This situation should not arise. And the next, the fourth point. Note down fourth point. If the bounded waiting is not satisfied, then it is possible for, guess करना चाहिए आप लोग. If the bounded waiting is not satisfied, then it is possible for starvation. It is possible for starvation. So if the bounded waiting is not satisfied, then it is possible for starvation. Understand here. So that is the meaning of fourth point. So understand carefully. Logical meanings. Understand each and every point carefully. Now, what is the heading says? The condition heading क्या है बताओ? Bounded waiting. Listen here. Bounded waiting. It's very very simple. Bounded waiting means. इसको देखते ही कुछ समझ में आना चाहिए. Bounded waiting. It means what? Waiting should be bounded. Simple point. Waiting should be bounded. Bounded means what? Limited. Waiting should be bounded. Bounded means what? Limited. Now, what the first condition you are having? No process should have to wait forever to enter into critical section. First point ko samjho. No process should have to wait forever to enter into critical section. It means what? Some processes keep on waiting to enter into critical section. ऐसा नहीं होना चाहिए. No process should have to wait forever to enter into critical section. Some processes keep on waiting to enter into critical section. That situation should not arise. कैसा होना चाहिए? ऐसा नहीं होना चाहिए. कैसा नहीं होना चाहिए? Some process keep on waiting to enter into critical section. ऐसा नहीं होना चाहिए. तो कैसे होना चाहिए? कैसे होना चाहिए? Second point. There should be a bound on getting chance to enter into critical section. There should be a bound on getting chance to enter into critical section. So bound means what? Limitation. So you should have a proper after how many processes it will get a chance to execute. Like for example, after 10 processes coming out of the critical section, then this will definitely get a chance. after two process coming out of the critical section, मतलब one by one, obviously one by one, दो process critical section के अंदर नहीं होगा obviously. So after two process coming out of the critical section, this will definitely get a chance to enter into critical section. Okay, after how many processes, it will definitely get a chance to enter into critical section. So that waiting should be bounded. मतलब आपको पक्का बोलना चाहिए. You have to clearly say after 5 processes, this will definitely get a chance. Okay, after 10 process, it will definitely get a chance. After 1000 process, it will definitely get a chance. Okay, the waiting should be bounded, limited. Point clear? Right. Next. Now, next, third point. Third point क्या है बताओ? Some process is indefinitely waiting to enter into critical section. Some process is indefinitely waiting to enter into critical section because critical section is always busy by some other process. This situation should not arise. इसका मतलब क्या है? Listen here. Now let's say you are having critical section here. You are having critical section. Now, okay, now look at here. Now process P1, okay, some process P1 is in the critical section here. Process P1 in the critical section. Listen carefully. Now process P2 is trying to enter into critical section. Process P2 is trying to enter into critical section. तो क्या हो गया? Okay, इसको busy मिलेगा. Right? इसको busy मिलेगा. Right? Remember, so P2 is trying, okay, it is finding busy. Now once P1 is coming out of the critical section, again some other process P3 coming into critical section. Again P2 trying, तो क्या मिल रहा है इसको बताओ फिर से? क्रिटिकल सेक्शन बिजी मिल रहा है. सो P3 बाहर गया, उसके बाद P4 आया, तो फिर से ये ट्राई कर रहा है, तो क्या होगा? फिर से इसको बिजी मिल रहा है. समझो अभी P2 प्रीएम्प्ट हो गया, और फिर से P4 बाहर गया और P5 आ गया, P5 अंदर आ गया, तो फिर से P2 ट्राई कर रहा है, तो क्या मिल रहा है इसको? फिर से बिजी मिल रहा है. ओके, P5 बाहर गया, तो फिर से P6 आ गया अंदर, मगर फिर से P2 ट्राई कर रहा है, तो क्या हो रहा है? P2 को फिर से क्या मिल रहा है? बिजी मिल रहा है. So it means what? Okay, so some process is indefinitely waiting to enter into critical section. Some process is indefinitely waiting to enter into critical section because critical section is always busy by some other process. So P4 आया, P6 आया, P7 आया, ऐसे हमेशा ये busy होते जा रहा है. तो ये जब भी ट्राई कर रहा है, इसको हमेशा busy मिल रहा है. P2 is indefinitely waiting to enter into critical section, okay, because critical section is always busy by some other process. Okay, remember what you have written. आगे क्या लिखे? This situation should not arise. ऐसा नहीं होना चाहिए, ऐसा नहीं होना चाहिए. कैसा होना चाहिए? हर प्रोसेस को डेफिनेट टाइम में क्रिटिकल सेक्शन के अंदर जाने के लिए चांस मिलना चाहिए. डेफिनेट टाइम में मतलब क्या है? डेफिनेट नंबर ऑफ प्रोसेस बाहर आने के बाद पक्का इसको चांस मिलना है. 2 प्रोसेस बाहर आते ही इसको पक्का चांस मिलेगा, इसका मौका मिलेगा. ओके, 100 प्रोसेस बाहर आते ही पक्का इसका मौका मिलेगा. सो ऐसा होना चाहिए. ऐसा नहीं है कि वो हमेशा ओके इंडेफिनेटली वेट कर रहा है, ऐसा नहीं होना चाहिए. इज अ पॉइंट क्लियर फॉर एवरीवन? राइट. सो सिंपल सी बात है. ओके, बाउंडेड वेटिंग, वेटिंग शुड बी बाउंडेड, बस इतना ही है. Okay, अलग अलग सिचुएशन को बताने के लिए to just verify all the various situations in the question, so I have given the different statements. Okay, again the meaning is same only, if your logical meaning is same only if you understand properly. And the last statement last statement you have written what? If the bounded waiting is not satisfied, if the bounded waiting is not satisfied, then it is possible for what? Starvation, obviously. So bounded waiting अगर नहीं है, if the bounded waiting is not there, so what is there? Indefinite waiting is there. So if the indefinite waiting is there, definitely what is there? Starvation is there. Okay, so the point is very clear, right? So this is the fourth statement you are having. Okay, so remember, you need to remember all these points carefully. Okay, that is the bounded waiting. Next, so next condition, that is the fourth condition. Okay, so fourth condition you have to follow. Note down this. Fourth condition you have to follow is no assumptions related to hardware and processor speed. No assumptions related to hardware and processor speed. Okay, इतना ही है, that's all. No doubt. Okay, so no assumptions related to hardware and processor speed. Copy करो. Okay, now it means what? Whatever the solution you provide to synchronize the processes, whatever the solution you provide, okay, to synchronize the processes, solution should work irrespective of any hardware and irrespective of any processor speed. You cannot say my solution works only on the specific hardware. You cannot say my solution works only on the specific process speed. It means what? The solution should be architectural neutral. Architectural neutral. It means what? Simple. Okay, it should work irrespective of any hardware and irrespective of any process speed. So that is the meaning of the fourth point. Now remember, the fourth condition is not very important. Fourth condition is not very important, but the first three conditions are important. First three conditions are very much required. It means what? Whatever the solution we are going to discuss in the future, whatever the solution we are going to discuss in the future, if it is following all these three conditions, then that solution is considered as a correct solution. Simple. Okay, if it is following all these three conditions, that is called as correct solution. If it is not following these conditions, that is called as what? Incorrect solution. Simple. If it is not following these three conditions, that is called as a incorrect solution. Is the point clear? Now remember, all these three conditions, all these three statements, conditions, they are not simple definitions. They are not the simple definitions. That is the actual concept you are going to implement in the question. That's the actual concept you are going to implement in the question. It means what? Okay, you will be given around 20 lines of code. Listen carefully. You will be given 20 lines of the code, and he will ask you simply mutual exclusion is satisfied or not satisfied. Now what the mutual exclusion definition says, only one process should present in the critical section. Now आपको 20 lines का code दिया गया. You have given around 20 lines of code. You have to check every possible case. Preemption ka case, no preemption ka case. What happens if I preempt after 5th line? What happens if I preempt after 7th line? What happens if I preempt after 12th line? Okay, all possible cases you have to check. Okay, whatever the way you try, if only one process is going into critical section, then you simply say mutual exclusion is satisfied. In case if you find a single case, in which the two processes are going into critical section at the same time, it means mutual exclusion is not satisfied. So how you are going to prove that? How you are going to disprove that? That all depends on your logical skills. Remember, the analysis and solution will change from problem to problem. Is that clear? Right. So I can just give you what is standard here is only definition is standard. If I ask you to check mutual exclusion, it is purely logical. आपको पूरा चेक करना पड़ेगा. यहाँ पे प्रेम करे तो क्या होगा, यहाँ पे करे तो क्या होगा, यहाँ पे करे तो क्या होगा, ये कैसा चल रहा है पूरा कोड. So हर एक लाइन को लॉजिकली समझना पड़ेगा. ओके, इसका मतलब क्या है, ये लाइन क्यों दिया गया, ये स्टेटमेंट क्यों दिया गया, इसको हटाए तो क्या होगा, इसके कर क्या रहा है ये स्टेटमेंट. So logically you have to understand every statement. Okay, you try in all possible ways. If there is only one process going into critical section, then you say mutual exclusion satisfied. And if you find a single case, okay, if there is two processes going into critical section, so it means mutual exclusion is not satisfied. So it is all depends on your logical skills, how you are going to solve the problem. So don't worry. So maximum we'll discuss the problems and you will understand all the techniques, but there is no any standard technique because it is a logical subject. Okay, concept is purely logical. Okay, you will experience all that going forward. So that is the reason generally I say whenever I teach synchronization, so I say synchronization is very important, and I say one more statement, synchronization is beautiful. Okay, so what is the meaning of beautiful? Beautiful means beautiful things are dangerous. Okay, why? Because what is the meaning of that is if you understand properly, if you deal properly, you will enjoy, otherwise you will break your head. Okay, right. So it means what? Concept is also really beautiful. Beautiful means if your logic is good, you really enjoy the subject. Okay, you really enjoy this entire concept. If a logic is good, you solve the problem only in 1 minute. If a logic is not good, you break your head, keep on solving problem, then also you will not solve. Idea आया, क्लिक हो गया तो 1 मिनट में हो जाएगा, नहीं हुआ तो 10 मिनट लगेगा, 15 मिनट लगेगा, depends. Is that clear? So no need to refer anything. So please follow the lectures carefully. I'll discuss everything. So I'm repeating again. If all these three conditions, don't worry about the fourth condition, it is not used much. okay, because you cannot check in the okay solution. पेपर में क्या चेक करोगे, क्वेश्चन आया, इसका हार्डवेयर क्या है, ओके, प्रोसेस स्पीड क्या है, वो सब नहीं दिया जाएगा, ओके, उसके बारे में नेग्लिजिबल स्टेटमेंट है. सो फर्स्ट 3 कंडीशंस, इफ एनी सॉल्यूशन व्हाट एवर यू डिस्कस, इफ इट इज फॉलोइंग दीज 3 कंडीशंस, then that is considered as what? A correct solution. If it is not following these conditions, then that is considered as a incorrect solution, wrong solution. Simple सी बात है. Is that clear? Right. So that is about a second step. Step number 2. So we have completed now step number 2. Next. Next. So we will discuss the okay step number 3. Now tell me what is the step number 3? We have a synchronization में क्या बताया, 3 स्टेप में मैं पढ़ाऊंगा. अंडरस्टैंडिंग सिंक्रोनाइजेशन फर्स्ट स्टेप हो गया, सेकंड स्टेप हो गया. नाउ द थर्ड स्टेप वी आर गोइंग टू डिस्कस, दैट इज द सॉल्यूशंस. द सॉल्यूशंस, ओके, नोट डाउन. What are the solutions available? Just make a note first. So first, okay, we will discuss software type of solutions. Copy karo. First note down the solutions what are available first. First we will discuss software type of solution. In this we will study lock variables. Next, strict alteration or Decker's algorithm. And next, Peterson's algorithm. Okay, so first okay, lock variable, strict alteration or Decker's algorithm. Next, Peterson algorithm. And the next, okay, next we'll study hardware type of solutions. Copy करो अच्छे से. Hardware type of solutions. In the hardware type of solution, we'll study TSL instruction set. TSL instruction set. So TSL मतलब क्या होता है? Test and set lock. टेस्ट एंड सेट लॉक. अगर आप स्लो लिख रहे हैं तो पास करके लिखो अच्छे से. ओके, सो ओके, हार्डवेयर टाइप ऑफ सॉल्यूशन विल स्टडी टीएसएल इंस्ट्रक्शन सेट. टीएसएल मीन्स टेस्ट एंड सेट लॉक. एंड द थर्ड विल स्टडी ऑपरेटिंग सिस्टम टाइप ऑफ सॉल्यूशन. ऑपरेटिंग सिस्टम टाइप ऑफ सॉल्यूशन, दैट इज काउंटिंग सेमाफोर. काउंटिंग सेमाफोर. एंड नेक्स्ट इज binary semaphore. Okay, operational type of solution. Okay, we'll discuss 2 things, counting semaphore and next is a binary semaphore. And next, the fourth type of solution we'll study programming language compiler support type. Okay, programming language compiler support type of solution. Programming language compiler support type of solution, okay, that we'll discuss. Okay, that is monitors. Okay, programming language compiler support type of solution, that is monitors. Okay, so these are the various solutions available and these are the solutions we are going to discuss. Okay, software type of solution, hardware type of solution, operation type of solution and programming language compiler support type of solution, that is okay, monitors. Okay, remember generally these 3 things are important and this is not important. Okay, so these are very important. Okay, programming language monitors is not important. There is no gate questions on the monitor at all. Okay, so when I am discussing all this, we'll solve the various okay questions, 20-25 gate questions I will solve in the classroom only. Okay, so please be serious. Okay, and okay, listen properly. Okay, and I want to give you small instruction. Okay, I am assuming all of you solving the workbook of 1, 2, 3 chapters. Okay, it is just like a regular class. Okay, whatever I am going to do in the regular class, offline class, I am doing the same thing. So maybe in the next session I will break up for 1.5 hour. I will discuss, come back and discuss the workbook. Make sure you solve your workbook from your end. कुछ भी पेंडिंग मत रखो आपके तरफ से वर्कबुक को. ओके, सारे क्वेश्चन सॉल्व करो. ओके, राइट. सो मे बी व्हेन आई डिस्कस बिफोर semaphore, before this one third type, I may discuss the workbook whenever. Okay, that depends on my wish. Okay, I am just giving you sufficient time. I am just waiting for you to solve the workbook, right? So that you keep in the mind. So next we are going to discuss the solutions. Okay, what is the meaning of that? Okay, so hope you are following. Okay, thank you. In the next session we will discuss the, maybe in the next video or maybe in the continuation. So we will discuss the solutions. Thank you. So dear students, next we will move on to the next one, that is solutions part. So in the previous session we have seen in the previous session we have discussed the conditions to be followed to achieve synchronization. So that is mutual exclusion, progress and the bounded waiting. So all of you know that I discussed everything perfectly. So okay, don't worry. So how to check and all that, okay, you will understand. Okay, going forward automatically you will understand. So next we'll move on to the solutions part. The first type of solution we have is software type of solution. Okay, so in the software type of solution, the first one we will discuss is lock variables. The first one we discuss lock variables. So keep the heading lock variables. So note down, copy this. Okay, keep the heading software type of solutions. The first one is lock variables. So in the entry section we will have this, copy this. Okay, okay, load the value of lock into register. So semaphore lock and this register RI. So compare CMP, compare register value with the 0. This is a hash number 0. Okay, number 0. Okay, and next the third instruction JNZ. Okay, it means what? Jump if it is non-zero to step 1. Jump if it is non-zero to step 1. And the next the fourth condition store the value of 1 into lock. And the next step critical section. Okay. Okay, so next okay, you don't require any specific instruction for this, even if you keep, no problem. Okay, so when you are leaving out of the critical section, so we are going to store the value of 0, okay, into the lock. And next the lock will take two values, either 0 or 1. So if the lock value is 0, that is the critical section is free, and if the lock value is 1, it means critical section is busy. So this is the code given to you in the lock variable solution. So just copy this. Copy this. Okay, pause my video. Okay, and copy. We are still not copied, so please pause my video and copy. So I am continuing explanation, you can pause. Okay, so understand here. So this is the code given to you in the lock variable solution. So what is the meaning of this solution and what we are trying to do in this? Let us try to understand. We are having common critical section here. We are having common critical section. So critical section means what? You will have the shared resources and the shared variables. See, critical section means what? Don't think what is critical section. So this is also what? A set of instructions. Okay, इसमें भी कुछ 10 instruction हो सकता है. Okay, it may contain 10 instructions or 10 lakh instructions. Okay, so that is all shared instructions, you can say. Is that clear? Right. So instead of writing all that, so we write simply block a critical section. So it means you understand inside that you will have the shared resources. Now remember, you are having common critical section between all the processes, and all the processes are trying to access the common critical section, and we are trying to provide synchronization to the processes to access the common critical section. To access the common critical section. Okay. Now remember, in the solution here, he has not mentioned any number of processes, like he did not say like it works only for 2 process or 3 process, nothing like that. So solution can be used by any number of processes. Solution can be used by any number of processes. Like, okay, in this when you do analysis, okay, you need to consider, okay, process P1, P2, P3, P4, P5 like this. Okay, you can consider any number of processes. Is that clear? Now remember, next in the lock variables, we are using a variable called lock. We are using variable called lock. The lock will take 2 values, either 0 or 1. The lock will take the 2 values, either 0 or 1. So if the lock value is 0, that indicates critical section is free. If the lock value is 0, that indicates critical section is free, and if the lock value is 1, that indicates critical section is busy. So that is the representation, okay, of the variable lock. Okay. And next, so I'll just go to the code here. Okay. So if you have any doubts, so please make the running notes. Okay, if you want to write in between. So now understand here, the first instruction, I'll just go to this. The first instruction, what you are having, load the value of lock into register Ri. So Ri, I means what? I means respective process register. Respective process register. So I told you already, respective process register. It means what? Every process will have its own register. So if you take process P1, so you have to take it as what? R1. So if you take P2, you have to take it as what? R2. Okay. So every process will have its own register. So we are loading the value of lock into register. That is the first instruction. And the second instruction is you are comparing the register value with the 0. Comparing register value with 0. So what is the meaning of this compare? Compare in the sense, what are the register value you are having? You are going to compare with the 0. See, why you are comparing with the 0 here? To identify whether critical section is free or busy, or say free or not. Okay. So that is the reason. Okay, you are doing the second instruction. You are comparing the register value with the 0. And next, the third instruction, look at here, J and Z. Okay, J and Z means what? Jump if it is non-zero. Okay, these instructions you will study in the computer organization. Okay, the basic instruction, no need to worry about that. Understand the meaning. So J and Z, jump if it is non-zero to step 1. So if it is non-zero, you simply asking to step 1 here. Okay, jump to step number 1. So if it is non-zero, what does that mean? If it is non-zero means, okay, the value is what? 1. Non-zero means 1. If it is 1, okay, what is that means? Critical section busy. So if the critical section busy, okay, the process will keep on executing in these instructions. So 1, 2, 3. So it's a 1, 2, 3. Same thing. Okay, load करेगा, compare करेगा. Non-zero है तो jump करेगा फिर से. लोड करेगा, कंपेयर करेगा, नॉन जीरो है तो जंप करेगा. इसलिए सो नॉन जीरो है तो जंप करेगा. ओके, नाउ इफ इट इज नॉन जीरो इट विल जंप टू द स्टेप नंबर 1. इफ इट इज 0 देन यू एग्जीक्यूट द नेक्स्ट स्टेप. Okay, so if it is 0 you execute the next instruction. So what is the next instruction here? Store the value of 1 into lock here. Listen, so we are storing the value of 1 into lock. M of lock, M means what? Memory location. So you are storing the value of 1 into lock. It means what? Okay, why you are storing the value of 1 into lock? It means you are locking the critical section. You are making the critical section to be busy. Is that clear? Because the process is now entering into critical section, so obviously you have to lock. So you are locking the value, okay, locking the critical section. So you are storing the value of 1 into lock, and then the process will enter into critical section. Then the process will enter into what? Critical section. So it will make use of the shared resources, shared variables here. Okay, it is also set of instructions only, right? Okay, so once it is completing the critical section, so then it will execute the next instruction. Now once it is completed the critical section, you are executing what? Store the value of 0 into lock. See, remember when the process is leaving the critical section, जब से वो CS छोड़ के बाहर जा रहा है, तो इसका मतलब obviously you have to okay release the lock. You have to make the critical section to be free. Okay, CS को आपको free करना पड़ेगा, critical section को free करना पड़ेगा. So free कैसे करोगे? By storing the value of 0 into lock. Is that clear? So understand important point. Understand important point. Unless and until the process is not executing instruction number 5, unless and until the process is not executing instruction number 5, you need to consider process is still inside the critical section now. Now, what is the meaning of this? ये सारे बात मैं क्यों बोल रहा हूँ? Okay, somebody may think like this. Okay, you are taking the preemption here. Okay, you are taking the preemption here and you are thinking that okay, now process is not in the critical section. That is wrong. Even if you take preemption here, okay, before executing this, okay, step number 5. Before executing step number 5, if you take preemption here, इसका मतलब क्या है? Process is still inside the critical section only. जब तक प्रोसेस ने लॉक वैल्यू 0 नहीं करेगा तब तक आपको मानना पड़ेगा प्रोसेस क्रिटिकल सेक्शन के अंदर है. इसलिए सो दैट इज अ इंपॉर्टेंट पॉइंट यू शुड रिमेंबर. ओके, सो दिस इज द कोड गिवन टू यू सो टू सिंक्रोनाइज द प्रोसेस. सो हाउ मेनी प्रोसेसेस आर देयर हियर? Any number of process like P1, P2, P3, P4, you can take consider any number of process. Now what we have to do here? अभी करना क्या चाहिए? Same thing. We need to check whether the solution given to you is a correct solution or incorrect solution. So we need to check properly whether it is a correct solution or incorrect solution. Now understand here, how do you know whether it is a correct solution or incorrect solution? Okay. Now, okay, if it is following our conditions, like what are the conditions? Okay, look at here. So, okay, mutual exclusion, progress and bounded waiting. If it is following that conditions, then you will say it is a correct solution. If it is not following that condition, then you will say it is a incorrect solution. Okay, so how we are going to check that? Okay, listen carefully. So I am doing the analysis here. So listen carefully. Okay, so in the analysis, okay, I am assuming initial value of the lock is 0. Initial value of lock is 0 and nobody is there in the critical section. Nobody is there in the critical section. Okay, initial value of lock is 0, nobody is there in the critical section, right? So now understand here. So let's say, okay, you can take any number of process here, okay, P1, P2, P3, P4 like that. So if any process wants to enter into critical section, okay, it will make use of the given code here, entry section, it will make use of this code here, right? So now understand here. So process P1, the answer is not just say, okay, in the analysis I am writing here. So process P1 executing the first instruction. Process P1 executing first instruction. What is the first instruction? We are loading the value of lock into register. So I have to take the separate register. Okay, look at here, R1. Every process will have its own register. Load the value of lock into register. So that is a 0. And next, now P1 executing the second instruction. P1 executing second instruction. What is the second instruction? Compare the register value with the 0. Now tell me, when you compare the register value with the 0, okay, look at here, when you compare the register value with 0, is it 0 or non-zero here? Non-zero. So, sorry, 0. Okay, when you compare the register value with 0, okay, uska bhi 0 hai, ye bhi 0, compare kar rahe, 0 ki 0, both are same or not. So, that is same only, so no problem, right? So, next, now P1 executing third instruction. So, what is the third instruction? Jump if it is non-zero to step 1. So, jump if it is non-zero to step 1. Now, tell me, will it jump here? Will it jump to the step number 1 here? No, because it is a 0. See, non-zero hai to jump karega. 0 hai to kyun jump karega? Nahi karega. Okay. So now, now it is executed third instruction. Now let us say after executing third instruction, I am assuming that process P1 is getting preempted. I am assuming process P1 is getting preempted. Preemption means what? Context switching ho raha hai. Process is going from running state to ready state. Let's say time quantum expired and process P1 is getting preempted. So now P1 is preempted. Okay. So now let's say I am scheduling some other process. Because if we are having any number of process, anything you can take. So next, now process P2 is coming into critical section, trying to enter. P1 का क्या हुआ था? Preempt हो गया. So now P2 is scheduled. Now P2 is trying to enter. So P2 also executing the first instruction. Because code is same for every process, so they will make use of same code. Now, first instruction, so I have to take the separate register for the P2 here, that is the R2. Look at here. So, first instruction क्या बोलता है? Okay, load the value of lock into register. So, what's the lock value? What's the lock value? आपके सामने है. Lock value क्या है? 0. So, load the lock value into register. So, that is a 0. And next, now P2 executing the second instruction. Okay, what is the second instruction? Compare the register value with 0. Now tell me, when you compare the register value with the 0 here, okay, is it 0 or non-zero? 0 only. So no problem, that is fine. And next, now process P2 is executing the third instruction. Process P2 executing third instruction. Tell me what is the third instruction? Jump if it is non-zero to step 1. When I say jump if it is non-zero to step 1, will it jump here? Okay, it will not jump. Remember, if it is 0, it will jump. Okay, non-zero, it will jump. Okay, so now it's 0, so no problem. And listen carefully. Next, now P2 is executing the fourth instruction. So now tell me, when P2 executing fourth instruction, what is the fourth instruction? We have store the value of 1 into lock. Listen, so now the lock value is getting updated. Now the lock value is getting updated. Okay, look at here. So lock value becomes what here? 1. So we are storing the value of 1 into lock. And next, now look at here. So now fourth instruction is completed. So it means what? The process is entering into critical section. So okay, next, once it is completed fourth instruction, remember P2 अगर आपका fourth instruction complete कर चुका है, P2 अगर fourth instruction complete कर चुका है, तो इसका मतलब कहाँ पे वो ऑटोमेटिकली वो critical section के अंदर ही है. Now small point I want to convey here also. अगर कोई process यहाँ पे preemption किया, यहाँ पे preemption किया, so you are storing the value of 1 into lock. अपन busy किया, already अपन okay lock में 1 किया, उसके बाद preemption किया. Now tell me, अगर यहाँ पे preemption होता है, okay, lock value 1 करने के बाद preemption होता है, तो अभी critical section free है या busy है? First point. ओके, यू आर स्टोर द लॉक वैल्यू एज अ 1. ओके, स्टोर किया अपन 1, स्टोर किया अपन लॉक में, उसके बाद यहाँ पे प्रीएम्पशन हो गया, क्रिटिकल सेक्शन में जाने के बाद प्रीएम्पशन हो गया. नाउ टेल मी, ओके, नाउ यहाँ पे प्रीएम्पशन हो गया, ओके, क्रिटिकल सेक्शन जाने से पहले प्रीएम्पशन हो गया. नाउ टेल मी, इफ समबडी इज आस्किंग क्रिटिकल सेक्शन इज फ्री और बिजी, व्हाट इज द आंसर? फ्री और बिजी? रिमेंबर, क्रिटिकल सेक्शन इज बिजी, फ्री नहीं है, बिजी है. वाई? बिकॉज अभी देखो सर ये कैसे बिजी है, देखो वो तो अंदर ही नहीं गया, यहाँ पे प्रीएम्पशन हो गया. यस, प्रीएम्पशन हो गया, बट वो क्या करके प्रीएम्पशन हो गया? लॉक वैल्यू 1 करके प्रीएम्पशन हो गया. इट इज ऑलरेडी मेड द लॉक वैल्यू एज 1 एंड देन गेटिंग प्रीएम्प्टेड हियर. इट मींस लॉजिकली इट इज ऑलरेडी मेड द क्रिटिकल सेक्शन बिजी and then it is getting preempted. Remember, even if it is getting preempted, preemption temporary stop. Preemption means temporary stop only, right? Time quantum is expired, the process is going from running to ready state. So again the process will be scheduled or not scheduled? It will be scheduled. So when the P1 is preempted here, if it is coming back, okay, there may be some process for P2, okay, if it is coming back, so will it enter into critical section? Yes. So that is the reason. Even if you take preemption here, no problem, the process will come back and directly enter into critical section. So you have to say critical section is busy only. Why? Because you already made the lock value as a 1. Okay, you already reserving the critical section. You are already reserving the critical section. So even if you take preemption, when the process comes back and directly enters into critical section, there is no condition checking on anything here. So what you have to say? Critical section is busy only, right? So next, okay, so now process P2 executing the fourth instruction. Okay, so that is done, and then the process will enter into critical section. So now P2 is entered into critical section. Is the point clear? Right. So now P2 entered into critical section. Now let us say P2 is okay, P2 is executing code in the critical section here. Critical section means what? That is also set of instructions only. Now P2 was in the middle of the okay execution of the critical section. Suddenly the P2 okay time quantum is also expired. Let's say P2 is also getting preempted. P2 is also getting preempted. Now let us say now the P1 is again scheduled. See, remember, you need to imagine the processes are scheduling, okay, by using round robin scheduling, okay, right, with some time quantum, okay, because practically we use what? Round robin only, okay. Now understand here. So now P2 is getting preempted. So P2 was in the middle of the critical section, okay, it was holding the critical section, and now it is getting preempted. So now P1 is coming back, okay. So when the P1 is coming back, now tell me, when the P1 coming back, which instruction it will execute? Okay, when the P1 was preempted after executing third instruction. So P1 was preempted here, okay, P1 was preempted here. So when the P1 is coming back, which instruction will execute? Fourth instruction. So look at here. So P1 is coming back and executing the fourth instruction. So when the P1 is executing the fourth instruction, so what does that means? Store the value of 1 into lock. So okay, this is storing the value of 1 into lock. Now remember, the lock value is already 1. So we are storing the value of 1 again here. We are storing the value of 1 again here. Now look at here. So P1 also executed fourth instruction, and then the P1 will comfortably enter into what? Critical section. Look at here. So P1 is comfortably coming into critical section again. So P2 was already executing the code in the critical section, and you preempted and you also bringing the P1 into critical section. So it means what? Both are accessing the shared variables at the same time. Both are accessing the critical section shared variables at the same time. It means what? What is the problem? What is the problem? Mutual exclusion is not satisfied. Mutual exclusion is not satisfied. Okay, so what is the important point you should remember? Okay, inside the critical section, how many processes should be present? Only one process should present inside the critical section. So, but what happened here now? The two processes are coming into critical section at the same time. So, it means mutual exclusion is not satisfied and solution is considered to be incorrect. Solution is considered to be incorrect solution. It means what? This is the wrong solution. So mutual exclusion ही fail हो गया, तो obviously that is a wrong solution. अब mutual exclusion fail हो गया, तो what is the problem here? Okay, what problem will arise? अगर दोनों process एक साथ में shared resource को access कर रहा है, तो फिर से क्या problem हो सकता है? Inconsistency problem हो सकता है. Inconsistency problem हो सकता है. Is that clear for everyone? Right? So this is the problem here, and it is not the correct solution. It is a wrong solution. So please copy the analysis here. Copy this. Pause my video and copy this. Okay, so note down the next important point. Okay, now I will discuss. If you have any doubts, I will discuss. Don't worry about that. Okay, now note down the statement. Continuation. We have proved. So statement ligo. We have proved that both the processes are coming into critical section. We have proved that both the processes are coming into critical section at the same time. We have proved that both the processes are coming into critical section at the same time. Hence, mutual exclusion is not satisfied. Hence, mutual exclusion is not satisfied and solution is considered to be incorrect. Solution is considered to be incorrect. So it means what? Wrong solution. Okay. Now understand here. So that is a wrong solution. Next. Now in the entire explanation, so somebody may have a doubt. Okay. So somebody may have a doubt. So what doubt you will have? So same thing. So why I am taking preemption after third instruction? So why I am taking preemption after third instruction? So what is the answer? What is the answer? Answer is no answer. Is that clear? So remember same thing. Okay, see, you have to imagine this code is used by the processes with the round robin and time quantum. Is that clear? So यहाँ पे preemption क्यों हुआ? Because answer no answer. Because preemption may occur at any point of time. So preemption may come after first instruction or after second instruction, after third instruction. So I am assuming that it is getting preempted after third instruction. Now the small point here. Okay, preemption तो कभी भी हो सकता है. Preemption may happen at any point of time. That is fine. Okay, after completion of the current instruction. But remember, why I am taking preemption only after third instruction? Because in the fourth instruction, what you are doing here? Storing the value. You are executing. You are storing the value of 1 into log. It means what? Okay, if I take preemption before the third instruction. If I take the preemption before the third instruction, I can dissatisfy the mutual exclusion. अगर आप fourth instruction चलाओगे तो आपको ये problem नहीं दिखेगा. If you execute this fourth instruction, you will not identify this problem. You feel that okay, it is working fine, because if you execute the fourth instruction, obviously other process cannot come into critical section. So you should get an idea that you should take preemption after, okay, third instruction. So if you get this in, okay, idea that you should take the preemption after third instruction, then you can clearly prove that, okay, both the process coming into critical section and mutual exclusion is not satisfied. Now remember, in the same manner, now it is actually easy, you can easily guess because load कर रहे हैं, store कर रहे हैं, तो आपको थोड़ा थोड़ा लग रहा है कि store करने से पहले preemption करो, okay. But remember, going forward, you will not have any load instruction, you will not have any store instruction. So he will give you the simple normal programming language code, okay, normal C language code, something like that, okay. Then also he will ask the simple question whether, okay, mutual exclusion satisfied or not satisfied. So you have to do the proper analysis like this by take what happens if I take preemption here, what happens if I take preemption here, what happens if I take preemption here. So you have to check all possible cases, and same thing, if you find even a single case where both the process coming into critical section, so it means mutual exclusion is not satisfied. So okay, you try in all possible ways, okay, only one process coming into CS, it means mutual exclusion is satisfied. Is the point clear? Right. So in this, okay, mutual exclusion is not satisfied. So solution is the incorrect solution. Okay. So did you write all that? Okay, statement likhe the na? Right. Okay. Right. So mutual exclusion itself is failed. Okay. So I am not checking for the other condition. Okay. We will do that in the next solution. Okay. Don't worry about that. We will do that in the next solution. Okay. Right. So next, in the continuation, we will move on to the next solution, that is strict alteration. Strict alteration or Decker's algorithm. Okay, copy karo, copy this. Process takes turn to enter into critical section. Process takes turn to enter into critical section. No doubt. Okay, process P0 code and process P1 code. Copy this. Okay, so I'll explain all that. So please make a proper copy of this. You can pause the video. I'll wait around 5 to 10 seconds in the live. Please make a proper copy. Okay. So understand here. So I am assuming, okay, all of you copied. So just listen here. Okay. So what is the meaning of this? So it's a strict alteration, or you say Decker's algorithm. So process takes a turn to enter into critical section. So in this we are using a variable called turn. Listen to me carefully. So in this we are using a variable called turn. So the turn takes two values. Okay, turn takes two values, either 0 or 1. Okay, so turn is a shared variable used by both the processes P0 and P1. Okay, remember turn is used by both the process P0 and P1, and the turn will take two values, either 0 or 1. So if the turn value is 0, that indicates process P0 is allowed into critical section. So if the turn value is 1, so process P1 is allowed into critical section. So that is the meaning of that. Okay. Now remember, in this we are having only two processes. So that is P0 and P1. So it is very clear, the solution is clearly saying that you are having only two processes. So there is no question of thinking about the third process. You are having only two processes, P0 and P1. So this is the code of the process P0 and this is the code of the process P1 here. And what we are trying to do, remember we are having common critical section. Don't think we are having two different critical sections. Remember, don't think you are having two different critical sections. You are having only one critical section, but what is different is code used by the process P0 is different and code used by the process P1 is different. Code used by P1 is different, P0 is different, and code used by P1 is different. Okay, right. So this is the code of the P0 and this is the code of the P1 here. So, okay, what we are trying to do, same thing, we are trying to provide synchronization to the processes to access the common critical section. हम लोग करना क्या चाह रहे हैं? We are trying to provide synchronization to the process to access the common critical section, and we say, we have to check. What we have to do now? We have to do the analysis and identify, okay, what is satisfied, what is not satisfied. So whether it is a correct solution or incorrect solution, we are going to identify that. Is that clear? Right. So I'll just go to the code first. Okay. So process P0 code while true. While true is a infinite condition. While true matlab whenever it is scheduled, it will execute. That is the meaning of that. So non-critical section. Non-critical section, it means what? Some independent code. Okay, kuch independent instructions ho sakta hai. And next, while turn not equal to 0, you are having semicolon. While semicolon is there. So while semicolon, already you know what is the meaning of this. So if this condition is true, the process will stop here. It will keep on rotating in the while loop for the condition to become false. So if the condition is false, okay, true hai to yahan pe ruk jayega. If the condition is false, it will enter into critical section. So critical section means what? It will be also have instructions only. Shared resource, shared variable, some instructions, shared instructions. So once it is completed the critical section, agar a condition false hai, to it will enter into critical section. So once it is completed critical section, while leaving, you say turn equal to 1. Okay. So this is the code of the process P0 here, and this is the code of the process P1. If you see the P1 code here, while true is a, okay, infinite condition, same thing, non-critical section, some independent code, while turn not equal to 1. So you are checking this condition. If the condition is true, the process will stop here, and if the condition is false, it will enter into critical section. And next, while leaving the critical section, you say turn equal to 0, and you will have the semicolon. Okay, semicolon miss ho gaya. Printing mistake ho gaya. Okay, right. So, okay, semicolon there. Right. So, while leaving critical section, you say turn equal to 0. So, this is the code of the P0 and this is the code of the P1. So, what we have to do? Abhi karna kya chahiye? Same thing. We need to do the analysis and identify, okay, whether it is a correct solution or a incorrect solution. So, when you will say it is a correct solution, if it is following our conditions like mutual exclusion, progress and all that. Samajh mein aaya sabko? Right. So, let us do the analysis. Okay. So, in the analysis, I am assuming initial value of the turn is 0 and nobody is there in the critical section. Okay. Initial value of the turn is 0 and nobody is there in the critical section. Okay. Right. So, now, okay. Now, let us say, okay, I am assuming process P0 is the scheduling first. Okay, anyone can execute first, no problem, right? So, I am assuming P1 is scheduled. Oh, sorry, P0 is scheduled. So, the P0 is scheduled while true is infinite condition. So, non-critical section, some independent code. And next, while turn not equal to 0, you are checking this condition. Tell me clearly, while turn not equal to 0, what's the turn value? 0. So 0 not equal to 0, true or false? 0 not equal to 0, true or false? कुछ लोग सोच रहे हैं, alright? So 0 not equal to 0, false. Okay. So if it is false, it will enter into critical section. It will enter into critical section. So now, okay, so P naught is comfortably coming into critical section. So I'm writing properly. So P naught is coming into critical section. So let your P naught be in the critical section. Okay, let your P naught be in the critical section. P naught को CS के अंदर रहने दो. Now try for process P1. Let's say P1 is also trying to enter. So let's see what will happen now. So P1 is trying to enter. Execute the code of the P1 while true. While true is infinite condition. So non-critical section, some independent code. And while turn not equal to 1. So what's the turn value here? Turn value is 0. So 0 not equal to 1. True or false? 0 not equal to 1. True or false? कुछ लोग false बोल रहे हैं. 0 not equal to 1 is true, right? So 0 is not equal to 1, true only, right? If it is true, the process will stop there and it will keep on rotating in the while loop here. समझ में आया सबको, right? So इसका मतलब क्या समझ में आया? When P naught is in the critical section, when P naught is in the critical section, if the P1 is trying to enter, so it is not possible to enter. It cannot enter into critical section. Okay. So, okay, P1 will execute this in, okay, while loop, and if it is true, so the process will keep on rotating only in the while loop. So, you read the turn value, check karega. If it is true, again check. You read the turn value and again compare, okay, check. If it is true, again rotate. So, it's keep on rotating in the while loop like this. Right. So, continue the analysis. Now, P naught is leaving the critical section. Listen carefully. So, P naught is leaving the critical section. So, when P naught is leaving the critical section, what happens? Okay, it will make turn value as what? 1. So, it will make the turn value as 1 and P naught is leaving the critical section. देखो, यहाँ से हटा दिया. Remember, if it is executing this instruction, it means what? P naught is leaving the critical section. Okay, already उसे छोड़ दिया CS को. Now, so now the turn value is 1. So, nobody is there in the critical section. Okay, listen carefully. Turn value is 1. Nobody is there in the critical section. Now, P1 is trying to enter into critical section. Okay, I am just checking. I am doing the various okay cases, observations. So, now P1 is trying to enter. So, let's see what will happen now. Okay, so while true is infinite condition. Okay, non-critical section, some independent code. While turn not equal to 1. What's the turn value? Okay, 1. So, if you, okay, observe here, turn value 1 hai. So, 1 not equal to 1, true or false? 1 not equal to 1, okay, false. If it is false, it will enter into critical section. So, now P1 is coming into critical section here. Okay, right. So, don't get angry, okay. So, maintain smile. So, listen here. So, 1 not equal to 1 is, okay, false. If it is false, it will enter into critical section. So, now P1 is coming into critical section. So, let your P1 be in the critical section. Now, try for the process P naught. Okay, समझो अपन P1 को CS में लाया, P1 को CS में रख के, so now try for the P naught. So the P naught is also trying to enter. So it's possible or not possible. So check करो, P naught is also trying to enter. Okay, while true, non-critical section, some independent code. Now while turn not equal to 0, what's the turn value? 1. Some है, turn value 1. So 1 not equal to 0, true or false? 1 not equal to 0, true or false? True. Okay, if it is true, the process will stop here. So it will keep on rotating in the while loop for the condition to become false. For the condition to become false. So it means what you understood. When the P1 is in the critical section, so P naught is not allowed. P naught is not allowed. So P naught try भी करता है तो यहाँ पे आके रुक जाएगा. So इसी में घूमता रहेगा. Next, now when the P1, okay, P1 कहाँ पे बताओ? P1 critical section में. Let's continue the analysis. Now P1 is leaving the critical section. So P1 बाहर जा रहा है. तो क्या करेगा? जब P1 बाहर जा रहा है, तो will make turn equal to 0. So very good. So it becomes turn value becomes 0. Turn value को 1 0 करेगा and P1 is leaving the critical section. So P1 बाहर चले गया. Right? So now what you understood? क्या समझ में आया अभी? So when P naught is in the critical section, P1 is not allowed, and when P1 is in the critical section, P naught is not allowed. You can try in any possible manner. Only one process will enter into critical section. So it means mutual exclusion is satisfied. Is the point clear? right? So the first condition, so I'll say, so the first condition I'll say mutual exclusion is satisfied. Okay, mutual exclusion is satisfied. Okay, so that is the first condition we have, mutual exclusion is satisfied. So the next, the second condition, okay, let's check for the second condition now. The answers say next. Now, okay, listen carefully. All the values are in front of you. Okay, all the values are in front of you. Now, what's the turn value? 0. Nobody is there in the critical section. Critical section koi process hai? No, there is no process present in the critical section. Turn value is 0. Now, let us say after some point of time, so P1 is trying to enter into critical section. P1 is trying to enter into critical section. So now tell me, okay, P1 is trying to enter. Check karo, P1 is trying to enter. While true, infinite condition. Okay, non-critical section, some independent code. While turn not equal to 1. Now tell me, what is the turn value? 0. So 0 not equal to 1. 0 not equal to 1. True or false? True. If it is true, the process will stop here. It will stop here. So it means it cannot enter into critical section. It cannot enter into critical section. So now what you understood here? Now critical section is free. Critical section is free. Nobody is in the critical section. Okay, P1 is trying to enter into critical section, but P1 is not able to enter into critical section. Is that clear? What is the problem? Problem क्या है बताओ? Progress is not satisfied. So progress का definition पे जाओ. Notes में लिखिए ऐसे जो definition था. Go to progress definition. Read the second point. Go to progress definition and read the second point. Notes turn करो. Second point क्या लिखे? If there is only one process trying to enter into critical section, then it should be definitely allowed to enter into critical section. So if there is only one process trying to enter into critical section, then it should be definitely allowed to enter into critical section. Okay, right? So now look at here. So only one process is there. It should trying to enter into critical section. So पक्का जाना चाहिए, मगर वो यहाँ पे नहीं जा रहा है. So it means what? Progress is not satisfied. Progress is not satisfied. Is that clear? So mutual exclusion is satisfied and progress is not satisfied. Okay. So I am repeating for the mutual exclusion once again. Mutual exclusion देखो, आप कुछ भी करो, कैसे भी करो. Mutual exclusion I am talking about. Okay, you can try in any possible manner. Okay, you take preemption, no preemption, do whatever you want. Only one process will enter into critical section. So that is the reason we are saying that mutual exclusion is satisfied. Okay, and the progress just now I discussed. Okay, there is only one process trying to enter into critical section. Okay, समझो P1 schedule हो गया, critical section free है, तो अभी P1 नहीं जा रहा है. So progress is not satisfied. So it means what? आपके पास resources खाली पड़ा हुआ है और कोई भी use नहीं कर रहा है. So obviously there is no progress. कोई progress नहीं है. समझ में आया? Right? Progress is not satisfied. So if you want, just copy these two things. ये दोनों copy करो. ये analysis में वो तो रफ किया मैं. Okay, so इसको copy करो. Only copy this. Okay, this one. And note down the statement. एक statement देता हूँ. Okay. If you are still copying, you can pause the video. Right. Note down the statement. Continuation में एक statement लिखो. We have proved that. Proved that progress is not satisfied. Progress is not satisfied. Hence, the solution is considered to be incorrect. Solution is considered to be incorrect. Okay, मतलब wrong solution. Okay, गलत solution है. Progress follow नहीं हो रहा है. So it is a wrong solution. Is that clear? Okay, is the point clear for everyone? Okay, yes or no? Okay, you have to say yes in the online. I am watching you. Okay, don't worry. Okay, so right. Okay, so fine. Next, in the continuation, okay, note down some points. Next, after this, you solve the gate question. So listen carefully. All of you following the class? Yes or no? Yes. If you are saying yes, so just drop a mail. Okay. I think all of you, I have given my mail ID balakrishna.virala, BALAKRISHNA, balakrishna.virala. Just okay, mail करके just yes बोल के लिख के mail डालो. Okay, I will be happy to see your mail. Right? Okay, fine. So come back to this. Okay, note down some important points. Note down. So okay, keep the heading important points. Keep the heading important points. Note down. First point. Preemption is just a temporary stop. Preemption is just, okay, just a temporary stop. The process will come back. The process will come back and continue. The process will come back and continue the remaining execution. Process will come back and continue the remaining execution. Okay. So preemption is just a temporary stop. The process will come back and continue the remaining execution. Okay. Point clear? Okay. I'll discuss. Don't worry. Okay. Note down the next second point. Note down second point. If any solution is having deadlock, note down, if any solution is having deadlock, then progress is, if any solution is having deadlock, then progress is not satisfied. Note down properly. If any solution is having deadlock, the progress is not satisfied. Just a minute, I am checking one more pointer. Okay, progress is not satisfied. Okay, क्या लिखे थे? If any solution is having deadlock, then progress is not satisfied. Okay. Next. Note down next point. Third point. If there is any possibility of solution becoming wrong, if there is any possibility of solution becoming wrong by taking the preemption, if there is any possibility of solution becoming wrong by taking the preemption, then consider the preemption. Then consider the preemption. Okay, right. Now remember all the 3 points whatever you have written. Okay, actually speaking I told you all that. इसलिए मैं already आपको बता चुका हूँ. Okay, so first point तो simple है. First point क्या लिखे थे? Okay, the preemption is just a temporary stop. Temporary stop, थोड़ी देर के लिए stop होगा. The process will come back and continue the remaining execution. See, remember why I am writing this statement here, why I am writing this statement, why I am giving that statement, because going forward you do so much analysis in the questions. Going forward you will do so much analysis in the questions. Some students may do the wrong analysis. Some students may do the wrong analysis, like okay, कुछ लोग ऐसा करते हैं, okay, wrong analysis, okay, like this process preempting here and okay, यहाँ पे preempt हो गया, उधर ही चले गया, okay, ये process यहाँ पे preempt हो गया, उधर ही चले गया. रिमेंबर किधर जाएगा बताओ, वापस आके कंटिन्यू करेगा. सिंपल, इसलिए सो प्रीएम्पशन इज जैसे टेम्पररी स्टॉप. ओके, टाइम क्वांटम एक्सपायर हो गया तो प्रोसेस रनिंग में से रेडी में गया तो वापस शेड्यूल होगा नहीं होगा? शेड्यूल पक्का होगा. इसलिए सो प्रीएम्पशन आप कहां पे भी ले सकते हैं, कहीं पे भी ले सकते हैं आफ्टर कंप्लीशन ऑफ द करंट इंस्ट्रक्शन, बट प्रोसेस को वापस लाके कंटिन्यू करके चलाना पड़ेगा. ऐसा नहीं कि वो यहाँ पे प्रीएम्प्ट हो गया उधर ही चलेगा, ये प्रीएम्प्ट हो गया इधर ही चलेगा, ऐसा थोड़ी ना होता है. ओके, किधर जाएगा सिस्टम से, राइट? सो प्रीएम्प्शन जस्ट टेम्पररी स्टॉप. ओके, प्रोसेस विल कम बैक एंड कंटिन्यू द रिमेनिंग इंस्ट्रक्शंस, राइट? ओके. So next, okay, for example, okay, listen here, same thing I am repeating. Okay, we are having 1 2 3 4 okay instructions. Let's say अभी second instruction के बाद preempt हो गया. प्रीएम्प्ट हो गया तो वापस आने के बाद कौन सा इंस्ट्रक्शन से चलाएगा बताओ. वापस आने के बाद कौन सा चलाएगा, थर्ड इंस्ट्रक्शन चलाएगा. अब बताओ, ओके, व्हेन द प्रोसेस कमिंग बैक इट विल एग्जीक्यूट थर्ड इंस्ट्रक्शन. सो हाउ इट विल नो इट हैज टू कंटिन्यू फ्रॉम द थर्ड इंस्ट्रक्शन ओनली. How it will know it has to continue from third instruction only? That is with the help of program counter. Program counter. So because program counter contains address of the next instruction to be executed. Address of the next instruction to be executed. So is the point clear for everyone? Right? So that is the reason. Okay, you should understand that point. Next, I think already I told you, okay, many times. Okay, next. Now coming to the second point. Second point क्या लिखिए? If any solution is having deadlock. If any solution is having deadlock, then progress is not satisfied. Okay, whenever any question is given, so in case you are having deadlock, then progress is straight away not satisfied. Progress straight away not satisfied. कोई भी solution में deadlock है, okay, so deadlock है या नहीं है, कैसे पता चलेगा? How do you know, okay, whether the that solution is having deadlock or not? Okay, you will understand going forward. Okay, let us say for example, okay, P1 is stuck up in the while loop and P2 is also stuck up in the while loop and both are not continuing execution. So that is called as what? Deadlock. Same thing, like P1 is depending on P2 and P2 depending on P1. Some variables they are updated and nobody continuing. They are locking each other. Nobody continuing execution. So that is called as what? Deadlock. Okay, so if a solution is having deadlock, okay, remember the progress is not satisfied. That is this, okay, superficial point, okay, important point, okay. So first you have to check the deadlock. Deadlock hai, to straight away progress not satisfied. So how you to check the deadlock? You will understand. Going forward, you will understand. Okay, आपका okay कोड चला रहा है सारे प्रोसेस का. आगे साथ सिचुएशन आ गया, ओके, दोनों एक दूसरे पे डिपेंड हो गया, दोनों वाइल लूप में फंस गया, दोनों वाइल लूप में स्टकअप हो गया और nobody is continuing execution. That is called as deadlock. If you are having deadlock, progress is not satisfied. Is the point clear? Right. So that, okay, second point you should remember. Next, the third point. Third point क्या लिखिए? If there is any possibility of solution becoming wrong by taking the preemption. If there is any possibility of solution becoming wrong by taking the preemption, then consider the preemption. Okay, इसका मतलब आपको लगता है कोई जगह preemption लेने से, ओके, कोई भी जगह प्रीएम्पशन लेने से सॉल्यूशन गलत होने का चांस है, तो वो प्रीएम्पशन को आप कंसीडर करना पड़ेगा. मगर कहां पे प्रीएम्पशन किए तो गलत होगा, वो कैसे मालूम होगा? वो तो आपको ही फाइंड करना है. Is that clear? Right. So you are having around 10 lines of code, 20 lines of code. Everything you have to check. Okay, where you have to take the preemption so that there is a chance of becoming wrong, solution becoming wrong. So if there is a chance, if we feel that okay, if you take preemption there and in that case, okay, the solution becomes wrong, then you have to consider that preemption. Is the point clear for everyone? Right. So if there is any possibility of solution becoming wrong by taking the preemption, then consider the preemption. अगर आपको लगता है कि इतना सारे कोड दिया गया, ओके, 10 लाइन का 20 लाइन का कोड, कोई भी जगह अगर preemption लेने से solution में गलत होने का चांस है, तो वो preemption को आप कंसिडर करना पड़ेगा. मगर कहां पे preemption करे तो गलत होगा, वो तो आपको ही फाइंड करना है. Is that clear for everyone? Okay, that is the third point. Okay, so these 3 points you have to consider while solving any question of synchronization. So you should remember that. Okay, so next we'll take up some gate question. Okay, so देखते हैं कितने लोग सही समझ रहे हैं अभी तक जो बताया गया. Okay, so go to your workbook. So keep the workbook just aside. Okay, just beside you. Go to your workbook. So I'll tell you page number. Okay, page number 94. Page number 94. Question number 15. Page number 94. Question number 15. So that question we are going to discuss. Oh, page number 94, sorry, I said 94 and written 95. Okay, fine, sorry. So page number 94, question number 15. Okay, operating system workbook, OS workbook, page number 94, question number 15. Read the question and solve by yourself. तब तक मैं क्वेश्चन लिख देता हूं, यहाँ पे क्वेश्चन पढ़ो अच्छे से, सॉल्व करो. Okay, now remember, okay, if you have solved the question, so not solved, then pause the video and okay, solve it by yourself. So let's see the solution. What is the right answer? So right answer is, shall I reveal the answer? Okay, if you are not solved, don't watch my video. Solve the question, then only you continue. Pause karo, solve nahi kare to. So right answer is, I am revealing. Okay, A is the right answer. Okay, कितना लोगों का सही आया? Okay, check कर लो. Right है. अगर किसी का गलत आया, ओके, म्यूचुअल एक्सक्लूजन बट नॉट प्रोग्रेस, दैट इज द राइट आंसर. ओके, सो आई विल एक्सप्लेन द क्वेश्चन. अगर किसी का गलत हुआ तो नो प्रॉब्लम, डोंट टेक टेंशन, जस्ट लिसन हियर. सो स्लोली, ओके, ट्राई टू इंप्रूव. क्या बोल रहे हैं क्वेश्चन में? ओके, S1 and S2 are the shared boolean variables randomly assigned. Okay, so let us do the analysis. Okay, so S1 and S2 are shared boolean variables randomly assigned. Okay, boolean variables. So boolean variables means what? 1 0 0 1 कुछ भी हो सकता है, right? So randomly assigned, so you can take anything. So 1 0 0 1 कुछ भी आप ले सकते हो. Exactly. Shared boolean variables means 1 or 0 only. So randomly assigned. So I am just assuming 1 0. Okay, so this is the code of the P1 here, this is the code of the P2 here, and you are having common critical section. Don't think we are having two different critical sections, we are having only one critical section, but what is different is code used by P1 is different and code used by P2 is different. Okay, so now, so this is the code of the P1 and this is the code of the P2. So let's say आप किससे भी चालू कर सकते हैं. Let's say I am starting with the P1 first. Now P1 is executing while S1 equal to S2. Tell me S1 equal to S2. S1 value 1, S2 value 0. So 1 equal to 0. True or false? False. If it is false, it will enter into critical section. So now P1 is coming into critical section. Okay, so let your P1 be in the critical section. Let your P1 be in the critical section. Now try for the P2. Try for the P2. Is it possible or not possible? So check करो. Okay, P2 भी आना चाह रहा है. तो क्या होगा? While S1 not equal to S2. So S1 value 1, S2 value 0. So 1 not equal to 0. True. So if it is true, the process will stop here. Process will stop here and will keep on rotating only in the while loop for the condition to become false. So when P1 is there in the critical section, so P2 is not allowed. Not allowed. So next, continue. Okay, continue the question. Now P1 is leaving the critical section. बाहर जा रहा है. तो क्या करेगा? S1 equal to S2 चलाएगा. So it means S2 value will be assigned to what? S1. So S2 value will be assigned to S1. So 0 will be assigned to S1. That is 0. Okay, and P1 is leaving the critical section. P1 बाहर जा रहा है. Okay. Now अभी P1 चले गया बाहर. Okay. Now when P1 okay बाहर गया तो now critical section is free. Now P2 is trying to enter. See देखो critical section खाली है तो कोई भी कभी भी आ सकता है, कितने बार भी आ सकता है, कितने बार भी जा सकता है. Okay, first that point you should remember. Next now P2 is coming here. So while S1 not equal to S2. Okay, P2 executing this. Okay, S1 not equal to S2. S1 value 0, S2 value 0. So 0 not equal to 0. True or false? False. If it is false, it will enter into critical section. So now P2 coming into critical section. Okay, remember now P2 in the critical section now. Let your P2 be in the critical section. Now try for P1. अभी P2 CS के अंदर है तो P1 भी आना चाह रहा है तो क्या होगा execute while S1 equal to S2, S1 equal to S2. So S1 value 1, S2 value, S1 value 0, S2 value 0. So 0 equal to 0. True or false? True. So if it is true, the P1 will stop there. So it means what you understood, when the P1 is there, P2 not allowed. When the P2 is there, okay, P2 not allowed. P1 है तो P2 not allowed, P2 है तो P1 not allowed. So continue. P2 अभी बाहर जा रहा है. P2 बाहर जाए तो क्या होगा? Okay, इसको चलाएगा. S2 equal to not of S1. So not of S1 will be assigned to S2. Remember, if you are executing this statement, so okay, this process is leaving the critical section. कुछ लोग क्या गलत किया? ये statement को चला रहा है, process को इसके अंदर ही रख रहा है. That is wrong analysis. Okay, so when you are executing this statement, so obviously it is leaving the critical section. So not of S1 will be assigned to S2. Not of S1. S1 value is 0. So not of S1 means what? 1. So that will be assigned to S2. So now, okay, and P2 is leaving the critical section. So it's got diya. Okay, so what you understood now? When P1 is there, P2 not allowed. P2 is there, P1 not allowed. You can try in any possible manner. You can try in any possible manner. Only one process is allowed into critical section. So it means mutual exclusion is satisfied. Okay. So I am writing here the first condition, mutual exclusion is satisfied. Right. So next, now coming to the second condition. Okay. Coming to the second condition. Now look at here. Now critical section is free. Nobody is there in the critical section. Now, after some point of time, P2 is trying to enter. After some point of time, P2 is trying to enter. Check करो P2 अभी जाना चाह रहा है तो जा पाएगा नहीं जा पाएगा. So while S1 not equal to S2, so S1 value 0, S2 value 1. So 0 not equal to 1. 0 not equal to 1 is true or false? 0 not equal to 1. True or false? True. If it is true, the process will stop here. Process will stop here. Look at here. Now critical section is free. Nobody is there in the critical section and P2 is trying to enter into critical section. So P2 is trying to enter into critical section, but P2 is not able to enter into critical section. P2 is not able to enter into critical section. Is the point clear for everyone? Right. So now critical section is free, but P2 is not able to enter into critical section. So what does that mean? Progress is not satisfied. Progress ka same. Okay. Second statement kya tha? If there is only one process trying to enter into critical section, that should be definitely allowed to enter into critical section. So it means okay, the progress okay is not satisfied. Progress is not satisfied. Okay, so this is how okay you solve the problem. Is that clear? Point clear for everyone? Right. So don't worry, आगे होगा. Okay, right? बैंड बजेगा. आगे बैंड बजेगा. अभी तो थोड़ा इजी चीज चल रहा है. ओके, सो इजी थिंग्स आर गोइंग ऑन, सो डोंट वरी. सो आगे बैंड बजेगा. राइट. सो फाइन. ओके, सो दैट इज अबाउट ओके द स्ट्रिक्ट ऑल्टरेशन or say Decker's algorithm. Simple and easy. Okay, and that is a gate question. Right. So next in the continuation, so we'll discuss the next Peterson algorithm and TSL instruction, and slowly we will enter into okay operational type of solution, that is semaphore. Okay, fine. Thank you.